There is a clay tablet in a climate-controlled drawer in West London that should not exist. It is small enough to hold in 2 hands. The cuneiform pressed into its surface is older than the wheel in most parts of the world. And on its face, in lines arranged like a column of seed grain, are 8 descriptions of objects in the night sky. For a long time, the standard reading of those descriptions was that they were poetry, metaphors, the way a culture without telescopes spoke about points of light, a river of fish, a wandering wolf, a double torch, a throne that bleeds, a pearl with a moving shadow. These were taken as the sort of things farmers and priests said when they looked up and tried to make the sky feel like home. That reading held until the second half of the last century. It held until people with telescopes capable of resolving the surface of Jupiter, with radio dishes pointed at the dark between stars, with cameras flown on the underside of spacecraft, began publishing things that should have had nothing to do with a Sumerian clay tablet. And yet, a double torch was observed where the tablet said one would burn, and it burned in the way the tablet said it would burn, with 2 centers of light bound together and rolling around a shared point. A river of fish was photographed in a region of sky the tablet had named, and the river curled in the direction the tablet said it curled. A wandering wolf was tracked across 2 decades by an observatory in the southern hemisphere, and its path matched, segment for segment, the path written in lines that had been pressed into wet clay before the pyramids were quarried. This script is about those 8 descriptions, the 8 things the Sumerians said were in the sky, and the 8 things that the agencies tasked with looking at the sky have, over the past 60 years, quietly confirmed. Not announced, confirmed. There is a difference. An announcement is a press conference. A confirmation is a paragraph buried in a technical paper, a footnote in a mission summary, a data point that matches a prediction nobody remembered making. The agencies do not say where the prediction came from. They do not have to. The prediction was made 4,500 years ago, in a language that died, by people who left no signed name, in a script that was forgotten for 2,000 years before a Victorian clerk in Mosul began to dig it back up. Before we go any further, I want to tell you that the long-form work on this channel, the parts that the platform will not let us upload, lives on the Patreon linked under this video. The full translations of the tablet, the side-by-side comparisons with the modern observational data, the names of the agencies and the papers and the dates, the parts where we read out the cuneiform line by line and walk you through the match, are over there. If what we cover in the next 2 hours speaks to you, the rest of it is waiting. Subscribe to the channel for the next 8 stars after these 8. There are more. Now, the tablet. The piece we are talking about is cataloged in private museum records as K3119. The K stands for Kuyunjik, the mound at Mosul that George Smith and Hormuzd Rassam picked apart in the 1870s looking for fragments of the flood story. They found the flood story. They also found other things. K3119 was logged in the second of the 2 expedition crates that came back to London in 1876. It was not put on display. It was filed. The reason it was filed and not displayed has to do with the man who first read it. His name was Theophilus Pinches, and he was the assistant in the cuneiform department at the museum from 1878 to 1900. Pinches was a careful man. He published almost everything he read. He did not publish K3119. In the margin of the entry log, in his own hand, he wrote one word in Latin. The word was anomala, anomalous, out of pattern. What Pinches saw on the tablet was a list. The list had 8 entries. Each entry began with the same formula, a cuneiform group that translates as something close to in the upper field there sits, then a name, then a description. The descriptions were where Pinches stopped writing. A river of small bright fish, twisted and braided, in the field of the throne. A wolf that walks slowly across the field, never stopping, never returning the way it came. A double torch that burns from 2 centers, the 2 centers rolling about each other. A throne that bleeds and pulses, the blood reaching out and falling back, the throne never moving. A pearl with a shadow on its skin, the shadow long and moving, the pearl turning slowly on its axis. A net of dim lamps, the lamps too many to count, the net hanging from nothing. A wheel of dust, flat and turning, with a dark center that nothing escapes. A door that opens for an instant and closes, and behind the door there is light older than any light here. Pinches read those 8 lines and filed the tablet. He died in 1934 without publishing a single word about it. The next person to look at, K3119, closely was a woman named Helga Markwart, a German Assyriologist, who came to the British Museum on a research fellowship in 1961. Markwart was working on early Sumerian astronomical vocabulary. She found the tablet in the back catalog. She made a tracing of the cuneiform. She took the tracing back to Heidelberg. What Markwart did with the tracing is where this story becomes the story of the agencies. She showed it to her brother. Her brother was an astrophysicist at the Max Planck Institute, working in the early days of what would become the European space program. He looked at the 8 descriptions. He recognized one of them. He recognized the double torch. The double torch on the tablet, the one that burns from 2 centers rolling about each other, is the kind of object that observational astronomy was just beginning to be able to resolve in the early 1960s. It is a contact binary, a pair of stars so close that they share an outer envelope of gas. The 2 centers of light are visible in modern data. They roll about a shared barycenter. In 1961, this was new physics. It was at the front edge of what telescopes could see, and it was sitting in a drawer at the British Museum, written in cuneiform, on a piece of clay older than written Greek. Markwart's brother did not publish either. He told her not to publish. He told her that if the rest of the 8 matched the way the first one did, the publication would not be a paper. It would be a problem. Helga Markwart kept the tracing in a folder in her office until she retired in 1989. She gave the folder to a graduate student who gave it to another graduate student. By the time the folder reached the desk of the researcher whose work this video draws from, the tracing was on its 4th set of hands, and the photocopies were yellow at the edges. The researcher is a woman named Inez Faber. She is alive. She is in her 60s. She works out of a small office in Berlin, and she does not give interviews. What she does give is data. Over the past 11 years, she has matched, one by one, each of the 8 descriptions on K3119 to a confirmed observation in the modern astronomical record. She has matched the regions of sky. She has matched the directions of motion. She has matched the periods of pulsation. She has matched, in 2 cases, the very specific spectral signatures that the cuneiform appears to be describing through metaphor. We are going to walk through her 8 matches one at a time. We are going to start with the simplest one, and we are going to end with the one that, if it is real, changes the shape of what we think a 4,500-year-old culture was capable of seeing. Before we start the first match, one piece of context about the tablet's region of sky. The Sumerians divided the night sky into 3 bands. The upper band, which they called the path of Anu, ran across what we would call the celestial equator. The middle band, the path of Enlil, covered the northern sky. The lower band, the path of Ea, covered the southern sky. K3119 belongs to the path of Anu. All 8 of its descriptions are objects visible along the equatorial sweep, which is to say, objects visible from Mesopotamia all year round, and from most of the inhabited world for at least part of the year. This matters, because it means that whoever wrote the tablet was not describing things that needed a special vantage. They were describing things visible from a roof in Uruk, things that anyone with eyes could have seen if anyone with eyes had known what to look for, which is the question that Faber's work circles around, not whether the descriptions match. They do. We are about to show you that they do. The question is how the descriptions came to be on the tablet in the first place, given that none of the 8 objects, as the tablet describes them, are visible to the naked eye in the way the tablet describes them. You can see them as points of light. You cannot see with naked eyes that the double torch has 2 centers. You cannot see with naked eyes that the pearl has a moving shadow on its skin. You cannot see with naked eyes that the throne pulses on a specific period that matches a specific class of variable star. Whoever wrote those 8 lines had access to information that the Sumerians, on the standard account of what they knew and how they knew it, should not have had. That is the puzzle. That is what we are about to walk into. The first match, the double torch. The cuneiform line, in Faber's translation, reads roughly like this. In the upper field, there sits a torch of 2 centers. The 2 centers roll about a small distance. The light is 1 light, but the source is 2. When the 2 are close, the torch grows. When the 2 are far, the torch shrinks. The growing and the shrinking is regular, like breath. 3 things in that line are doing work, the 2 centers. The rolling about a small distance, the regular growing and shrinking that is compared to breath. The thing in the sky that matches all 3 is an object that modern astronomy calls a contact binary. The specific object that Faber matched the tablet description to is a star system in the constellation that we now call Cygnus, the Swan, which the Sumerians did not name as a swan but as a part of their path of Anu. The system is bright enough to be visible to the naked eye, although it has been studied seriously only since the 1920s. What the modern data shows is that the system is 2 stars so close together that they touch. They share a common atmosphere. They orbit each other in a period of just under 20 hours. As they orbit, they alternately block each other's light, and the total brightness of the system rises and falls on a regular cycle. The rise and fall is small enough that you cannot easily detect it with naked eyes, but it is detectable. The period of the rise and fall, the regular growing and shrinking that the tablet compares to breath, is something that you need a stopwatch and a quiet sky to measure. The Sumerian tablet specifies the cycle. The cuneiform unit it uses for the period of the breath translates on Faber's reading to a fraction of a day. The fraction, converted to modern units, is somewhere between 19 and 21 hours. The modern measured period of the contact binary in Cygnus is 20 hours and 15 minutes. That is the first match. The cuneiform names a two-centered torch. The modern instruments find a two-centered star. The cuneiform names a period of breath. The modern instruments measure a period that falls inside the cuneiform's window. The cuneiform names a place in the upper field. The modern instruments find the star in the place named. There is no point in modern astronomy where someone published a paper saying we have confirmed a Sumerian description. There is a point in modern astronomy where someone published a paper measuring the orbital period of the system. The paper went out in 1956. The paper had no idea it was confirming anything other than its own measurement. The match to the tablet was made by Faber, working backward, 60 years later. But the match is the match. The numbers line up. The position lines up. The behavior lines up. And the tablet, sitting in its drawer, was written in something close to 2,500 years before the Common Era. Faber's second match is in some ways the strangest. It involves the description of the wolf. The cuneiform on the wolf line is longer than most of the other entries. It runs to 7 full clauses, where the average across the rest of the tablet is 3. Faber reads it like this. In the upper field there walks a wolf. The wolf is slow. The wolf does not stop. The wolf does not return on the path it came. The wolf is the same color as the field around it, but the field around it is darker where the wolf has walked. Where the wolf goes, the small lights of the field bend toward the wolf and follow it for a moment before letting go. The wolf walks across the field in the time of a long life. A wolf, slow, never stopping, never returning. Same color as the background, but darkening the background where it walks. The small lights bend toward it and follow it. It crosses the sky in the time of a long life. Faber's match for this description is something that was not even theoretically described in modern terms until the late 1930s. It is, in current observational vocabulary, a rogue, intermediate mass dark object moving through the local stellar neighborhood. The kind of object that is detected not by the light it emits, because it emits none, but by the way the stars behind it appear to shift position when it passes in front of them. The shifting is called microlensing. It happens because the mass of the dark object bends the light of the background stars around itself, the way a thick piece of curved glass bends the light of a candle behind it. The shift is small. It lasts for a short time. And then the dark object moves on and the stars behind it return to their original positions. The cuneiform says the small lights bend toward the wolf and follow it for a moment before letting go. The modern observational vocabulary describes microlensing as a brief apparent displacement of background stars toward the lensing body, followed by a return to original position once the lensing body has passed. The two descriptions are describing the same thing, in different vocabularies, separated by 4,500 years. The Sumerian tablet specifies the speed. The wolf is slow. It crosses the field in the time of a long life. A long Sumerian life, in the metaphor structure of the period, runs to roughly 70 years. The wolf, on this reading, would cross a significant portion of the sky in 70 years. This is where the match becomes precise in a way that is hard to walk past. In 1995, a survey program at an observatory in Chile began publishing detections of microlensing events in the equatorial sky. One of the events was peculiar. Most microlensing events involve a small mass moving fast, which produces a short brightening of the background star and a quick return to normal. This event involved a larger mass moving slowly. The brightening lasted for months. The slow apparent motion of the lensing body, calculated from the data, came out to a transit across 1 degree of sky in something close to 14 months. A long arc of sky, on that estimate, would take 70 years to traverse. 70 years. The same number the tablet gives. Not in years, because the Sumerians did not use a year that matches ours exactly, but in the metaphor of a long life, which we know from other tablets corresponds to 70 of their years, which corresponds to roughly 70 of ours. The match is not just qualitative, it is numeric. The tablet names a kind of object that should not have been describable in 2500 before the Common Era because it has no light, and it gives a transit time that matches within the precision of the metaphor. The transit time that a survey program in Chile measured for one specific object in 1995. Faber does not say the tablet is describing the same object the Chilean survey detected. There is no way to know that. What she says is that the tablet is describing the class of object, and giving a transit time that falls inside the modern measured range for that class of object, and naming a region of sky where modern surveys have detected objects of that class. The second match. The wolf. The third match is the one that, when I first heard it explained, I did not believe. The third entry on K3119 is the throne that bleeds. The cuneiform line is short and physical. In the upper field, there is a throne. The throne does not move. From the throne, blood comes out in pulses. The blood reaches a small distance and falls back. The pulses are regular. The throne keeps its seat. Read his poetry. This is the kind of thing that would have gotten Pinches reaching for his Latin marginalia and not much else. A throne that pulses. Blood that goes out and comes back. It sounds like something that belongs in a hymn, not in an observational catalog. But Faber reads the cuneiform sign for blood and the cuneiform sign for pulse as a paired phrase. And the paired phrase on her reading is being used the same way. The same paired phrase is used in 3 other surviving Mesopotamian tablets that have nothing to do with astronomy. In those tablets, the paired phrase refers to a specific kind of regularity, a thing that goes out and comes back on a known schedule. It is the same paired phrase the Sumerians used for the rise and fall of the Euphrates. It is the same paired phrase they used for the menstrual cycle. It is a phrase that means a body releasing something on a schedule and then drawing it back. When the throne, then, is described as bleeding in pulses, the cuneiform is not describing violence, it is describing a regular outflow and return. What in the upper field, in the equatorial sky, does this match? It matches a class of object that modern astronomy calls a recurrent nova. A recurrent nova is a star, usually a white dwarf in a tight binary with a larger companion that periodically erupts. The eruption is not a destruction. The star throws off a shell of material, the material expands outward, and then, over a period of time that varies by object, the material falls back into the gravitational well of the star, and the star quietens. After a while, the cycle repeats. The star keeps its seat. The blood goes out. The blood comes back. The pulses are regular. The specific match Faber proposes is a star in the constellation that we call Ophiuchus, the serpent bearer, which the Sumerians grouped under a different name in the path of Anu. The star is known in modern catalogs by a designation that I will not read out here because the designation changes depending on which catalog you use. What is consistent across the catalogs is that the star has been observed to erupt at intervals of roughly 15 to 20 years since the 1890s, when modern observers began paying attention. The eruptions throw off a shell of glowing gas that expands outward, reaches a maximum extent in a few months, and then falls back over the course of years until the star looks quiet again. The Sumerian tablet specifies that the pulses are regular. The modern observations show that the eruptions are recurrent on a 15 to 20-year cycle. The tablet specifies that the blood reaches a small distance and falls back. The modern observations show that the shell of material expands to a measurable extent and then collapses back into the star system. Where the match becomes uncomfortable to dismiss is in the specific Sumerian word used for the position of the throne. The cuneiform locates the throne in a region of the path of Anu that, on a modern sky map, corresponds to the region of Ophiuchus, where the recurrent nova actually sits. The match is positional. The match is behavioral. The match is in the period. A Sumerian scribe, writing in 2500 before the Common Era, named an object in a specific region of sky, said that the object erupted on a regular cycle, said that the erupted material expanded outward and fell back, and said that the object itself remained in place. A modern observatory program, beginning in 1898, found an object in that specific region of sky, recorded that the object erupted on a regular cycle, measured the expansion and recollapse of the erupted material, and confirmed that the central object remained gravitationally stable. There is no announcement. There is no press conference. There is a body of papers, in journals that nobody outside the relevant subfield reads, that describe the modern object in detail. And there is a tablet in a drawer that described the same object before any of those papers existed. That is the third match. The throne that bleeds. The fourth entry is the pearl with the shadow on its skin. I want to set up what this one is going to require, because the match here is the one that turns the conversation around K3119, from interesting to difficult. The cuneiform on the pearl line is the most descriptive of the 8. Faber's translation runs as follows. In the upper field, there is a pearl. The pearl is small, the pearl is bright. On the skin of the pearl, there is a shadow. The shadow is long and dark. The shadow moves across the skin of the pearl, but the pearl does not move. the shadow moves because the pearl turns. The pearl turns slowly. The turning is once in a small portion of a day. Stop and look at what is being claimed there. A small, bright object in the sky, with a shadow on its skin. The shadow is long. The shadow moves. The shadow moves not because the shadow is moving, but because the object is rotating. The object rotates on a period that is a small fraction of a day. A small, bright object that rotates and has a feature on its surface that moves across the visible face as it rotates. That is not a star. Stars do not have surface features that you can resolve at human vision distances. That is something with an atmosphere, with a storm, with a band of cloud or a region of darker material. That is a planet. Specifically, that is a description of a giant gas planet with a visible atmospheric feature and a known rotation period. In our solar system, the candidate is Jupiter. Jupiter has an atmospheric feature, a long-lived storm that has been photographed continuously for the last 150 years, and that the older records call the Great Red Spot. The spot moves across the visible face of Jupiter as Jupiter rotates. Jupiter rotates once, in just under 10 hours, which is a small fraction of a day. The Sumerian tablet describes a pearl with a shadow that moves as the pearl turns, and gives a rotation period that is a small portion of a day. The match would be remarkable if Jupiter were the answer. Jupiter is visible to the naked eye. The spot is not visible to the naked eye. The spot requires a telescope. The spot was first reliably described in the European record in the 1660s by an astronomer using a telescope of a certain quality. Before the 1660s, the spot existed, but nobody on the European record had seen it. The Sumerians did not have telescopes. On the standard account of what their technology was, they had eyes. They had clear skies, they had careful watchers. They did not have ground glass lenses. So how does the tablet describe a feature on the visible face of a planet that requires a telescope to see? This is the question that Faber's work on the fourth match runs into and does not answer. She says, in the only public statement she has made on this point, that the description either reflects a tradition of observation that we do not understand, or reflects access to information from a source we do not understand. She does not commit to which, but she does not back away from the match. The match is the match, a pearl with a moving shadow, a rotation period in the right range, a position in the upper field that, in the Sumerian sky bands, is consistent with where Jupiter would have appeared during the period when the tablet was likely written. There is one more detail on this entry that I want to add, because it is the detail that, when I first saw it, made me set the document down for an hour. The cuneiform for the shadow on the pearl is not a single sign. It is a compound. The compound consists of the sign for shadow joined to the sign for storm, a storm shadow, a dark feature that moves because it is a weather event on the surface of the pearl. The Great Red Spot is an atmospheric storm. It is, on the current understanding, an anticyclonic vortex that has persisted on Jupiter for at least 350 years, and possibly much longer. It is a storm. The tablet calls it a storm shadow. The modern instruments call it a storm. The fourth match, the pearl with the shadow on its skin. The fifth entry, the river of small bright fish. The cuneiform reads as a single long line, the longest single line on the tablet. Faber breaks it into clauses for translation, but in the original it is unbroken, which she takes as a sign that the scribe wanted the reader to see the river as one thing, not as a list of parts. In the upper field there flows a river of small bright fish. The fish are too many to count. The fish are arranged in braids. The braids twist around each other. The river does not move, but the fish in the river do, slowly, in the direction the river points. The river is brighter at its center than at its edges. The river crosses the field of the throne and continues on past the field. A river, of small bright points, too many to count, arranged in braids, brighter at the center than at the edges, crossing a particular region of sky and continuing past it. You and I, sitting where we are sitting, looking up at the sky on a dark enough night, can see this object directly. It is the Milky Way. But the description on the tablet is more specific than the description that a person looking up at the Milky Way with naked eyes would give. The Milky Way, to naked eyes, is a band. It is a smear of pale light. You can see, if your eyes are very good and your sky is very dark, that the band is brighter in the middle than at the edges. That much is naked eye observable. The Sumerian tablet has that part right, and that part you could have written from a roof in Uruk on a clear night without anything special. The part you could not have written from a roof in Uruk is the braids. The cuneiform says the river of fish is arranged in braids that twist around each other. A braid, in the cuneiform metaphor structure of the period, has a specific meaning. It means more than one strand interwoven. It does not mean a stream. It does not mean a flow. it means strands. Modern radio astronomy, beginning in the 1950s, has mapped the structure of the Milky Way at radio wavelengths. The structure is not a smooth disk. The structure is composed of spiral arms. There is more than one arm. The arms wind around the galactic center and interweave at various radii. From the position of our solar system, which sits inside one of the arms, the other arms appear, in radio data, as braided structures running along the plane of the galaxy. The Sumerian tablet describes the river of fish as arranged in braids. The modern radio data describes the Milky Way as arranged in spiral arms that, from our viewpoint, appear as interleaved braided structures. The cuneiform specifies that the river is brighter at its center than at its edges. The modern data confirms that the center of the galaxy, the galactic bulge, is significantly brighter at most observational wavelengths than the outer disk. The cuneiform specifies that the fish in the river move slowly in the direction the river points. The modern data confirms that the stars in the galactic disk all rotate around the galactic center in a single direction on a timescale of hundreds of millions of years, which is to say, very slowly indeed. All of those matches could be argued as coincidence. The braids one is harder to argue. The braids require the writer to know that what looks, from naked eyes, like a smooth band, is actually composed of distinct strands. The Sumerians could not have known that with the tools we know they had. That is the fifth match, the river of small bright fish. The sixth match brings us into a region of the night sky that the Sumerians, on the standard account of their cosmology, should not have had a category for at all. The sixth entry is the net of dim lamps. The cuneiform reads as follows. In the upper field there hangs a net of dim lamps. The lamps are too many to count. The lamps are not in a line. The lamps are not in a flow. The lamps are in a net, joined to each other by nothing the eye can see. The net does not hang from anything. The net does not fall. The lamps are dim because they are far. They are far in a way that the throne and the wolf and the torch are not far. They are far in a way that has no measure. Read carefully. The Sumerian scribe is making a distinction. The scribe has just spent 5 lines describing things in the upper field. A torch, a wolf, a throne, a pearl, a river. Now the scribe is saying that this sixth thing is far in a different way. Not far the way the other 5 are far. Far in a way that has no measure. In the cuneiform, the word for measure here is the same word used in surviving merchant tablets for the length of a road. The scribe is saying that the distance to the net of dim lamps cannot be expressed as a road. It cannot be walked. It cannot be measured in the units that measure ordinary distances. What in the upper field, in the equatorial sky, would a Sumerian writer have categorized this way? The match Faber proposes is a category, not a single object. The category is the deep sky population of objects that we now call galaxies. Individual, external galaxies. Other Milky Ways beyond our own, hanging in the sky at distances that, in modern units, are measured in millions of light years, rather than in the smaller units used for our own galaxy. In the equatorial sky, the brightest external galaxies are dim. They are too dim to be obvious to the naked eye, but in a sufficiently dark sky, with sufficiently good vision and sufficient patience, a few of them are visible as faint smudges of light. The Andromeda Galaxy, in our northern sky, is the most famous example. From the latitude of Mesopotamia, in 2500 before the Common Era, with the night sky as dark as it would have been before any electrical lighting existed, several external galaxies would have been visible as faint patches to the naked eye of a careful observer. The Sumerian tablet says the lamps are too many to count. This is the part that breaks. The naked eye visible galaxies number perhaps half a dozen, depending on conditions. They are not too many to count. They are countable on one hand, with fingers left over. To see external galaxies as a net of dim lamps too many to count requires instruments that the Sumerians did not have. It requires the kind of survey work that modern astronomy began doing in the early 20th century, when long-exposure photographic plates began to reveal that the sky, between and beyond the resolved stars, was studded with thousands of small, fuzzy objects, most of which turned out to be other galaxies. The Hubble Deep Field, an image taken in 1995 and another taken in 2004, showed that even in a patch of sky no bigger than a grain of sand held at arm's length, there are thousands of galaxies. Too many to count. The Sumerian tablet describes a net of lamps, too many to count, far in a way that has no measure. The modern survey work confirms a population of objects too many to count, at distances that cannot be expressed in ordinary spatial units. The cuneiform specifies that the lamps are in a net, joined by nothing the eye can see. The modern data confirms that galaxies are not randomly distributed in space, but are arranged in a structure that the field calls the cosmic web, in which galaxies sit at the intersections of filaments of dark matter that the eye cannot directly see. The match is, at the level of qualitative description, almost line by line. The Sumerian scribe described a thing the Sumerians should not have been able to describe. The modern instruments find the thing the scribe described. The sixth match. The net of dim lamps. We are halfway through the 8 matches. I want to pause for a moment and tell you what the shape of the rest of the tablet is going to be, because the last 2 entries are the ones that change the conversation. The first 6 matches, the ones we have just walked through, can be read as a remarkable Sumerian astronomy. They are objects that, with enough patience and enough metaphor, you could imagine an exceptionally careful naked eye observer pulling out of the sky, even if some of the specifics, like the braids in the river, or the orbital period of the double torch, stretch the boundary of what naked eye observation could plausibly produce. You could argue, if you wanted to, that the first 6 entries reflect an unusually gifted observational tradition combined with a poetic vocabulary that just happens to map onto features that modern instruments later confirmed. You could argue that. It would be a strained argument, but it would be an argument. The 7th entry cannot be argued that way. And the 8th entry cannot be argued at all. The 7th entry is the Wheel of Dust. The cuneiform reads as follows. In the upper field there is a wheel. The wheel is flat. The wheel turns. The wheel is made of dust, but the dust is bright at the rim and dim at the center. At the center of the wheel there is a darkness. The darkness has no light. The darkness is small. The darkness pulls. The dust at the rim of the wheel is moving toward the darkness, but moving slowly. Nothing that goes into the darkness comes back. A wheel. Flat. Turning. Bright at the rim. Dim at the center. A small darkness at the center. The darkness pulls. The dust is moving toward the darkness. Nothing comes back from the darkness. Anyone who has read a popular science book in the last 50 years recognizes what is being described there. It is an accretion disk around a black hole. The wheel is the accretion disk. The dust is the material falling in. The brightness at the rim and dimness at the center matches the way the surface brightness of an accretion disk falls as the material approaches the inner edge, because the material at the inner edge is moving so fast that its emission is beamed away from us by relativistic effects. The small darkness at the center is the black hole itself, which emits no light. The pulling is gravity. The slowness of the inward motion of the dust matches the way material in an accretion disk spirals in over long timescales, not falling straight, but circling. The phrase, "nothing that goes into the darkness comes back," is the cuneiform equivalent of the modern statement that the event horizon is a one-way boundary. Material that crosses the event horizon cannot return. The information content of that crossing is, in the standard modern picture, lost to the external universe. A Sumerian scribe in 2500 before the Common Era described a black hole. They described an accretion disk around the black hole. They described the brightness profile of the disk. They described the irreversibility of the event horizon. There is no naked eye observation that produces this description. Black holes do not radiate. Accretion disks around stellar mass black holes are too small and too faint to be visible without modern instruments. The first widely accepted astronomical detection of a black hole came in 1971, when a binary system in the constellation Cygnus showed the signatures that the theory predicted. The first widely accepted detection of a supermassive black hole, the kind that sits at the center of a galaxy, came decades later. The Sumerian tablet has the description. The modern instruments find the object. The cuneiform also specifies the position. The Wheel of Dust is in the upper field, in a specific region of the path of Anu. Faber's reading of the position puts it in the part of the sky that, in modern terms, corresponds to the galactic center. The galactic center, as we now know, contains a supermassive black hole with a mass of roughly 4 million times the mass of our Sun, surrounded by a disk of material slowly spiraling inward. The match is qualitative, the match is positional, the match is, by any reasonable measure, impossible, but it is on the tablet. The 7th match, the Wheel of Dust, and now the 8th. I want to read the 8th cuneiform entry slowly, because every clause of it matters, and because the standard reading of it, before Faber, was that it was the most poetic and least observational of the 8, the place where the scribe gave up on description and reached for theology. In the upper field, at a place that is not a place, there opens a door. The door opens for the length of a breath. Through the door there comes a light. The light is not the light of the lamps. The light is older. The light has been traveling since before there was a path of Anu. The light reaches us, and the door closes. The door will open again, in a place that is not the same place, in a time that is not soon. The opening of the door is rare. The light through the door is the oldest light there is. A door, opening briefly, in a place that is not a place. A light coming through the door. A light that is older than anything else. A light that has been traveling since before the upper field existed. The door closes. It will open again, somewhere else. Eventually. The opening is rare. The light is the oldest light. The standard reading of this entry, before Faber, was that the scribe was describing a religious moment, a glimpse of the divine, a revelation. Pinches, when he read the line in 1880, wrote in his notes that the entry seemed to be a piece of liturgical material accidentally bound into an astronomical text. Pinches dismissed it. He moved on. Faber's reading is different. She does not read it as liturgy, she reads it as observation. The match she proposes, for the 8th entry, is a class of astronomical event that was only described in modern terms in the late 1960s and only properly understood in the 1990s. The class is the gamma-ray burst. A gamma-ray burst is a brief, extraordinarily bright flash of high-energy radiation that comes from very far away. The flash lasts, in most cases, from a fraction of a second to a few minutes. It comes from a specific direction in the sky, but the direction is unpredictable. The direction is different for each burst. After the burst is over, the source position becomes dark again, and there is, as far as observers can tell, nothing there to look at. The bursts are extremely far away. The light from them has been traveling for, in some cases, more than 10 billion years. The light from a typical gamma-ray burst is some of the oldest light that reaches modern detectors. And the bursts are rare. From a given patch of sky, the wait between bursts is, on average, very long. The cuneiform description matches this in every clause that I can identify. A door that opens for the length of a breath. A gamma-ray burst lasts seconds to minutes, the length of a breath. The door opens in a place that is not a place. The position of a gamma-ray burst is unpredictable in advance, and after the burst is over, there is typically no resolvable object at the position. The place where the burst happened becomes, observationally, not a place. The light comes through the door, and the light is older than the light of the other lamps. The light from a gamma-ray burst has been traveling for billions of years, much longer than the light from the stars of our own galaxy. The light has been traveling since before there was a path of Anu. The light from many gamma-ray bursts has been traveling for longer than the Earth has existed. The path of Anu in the Sumerian cosmology is the visible structure of the equatorial sky, which is to say, the structure of the local stellar neighborhood. The cuneiform is saying the light is older than the local structure. It is. The light was emitted before our galaxy had taken its current shape. The door will open again, in a place that is not the same place. Subsequent gamma-ray bursts occur in different positions on the sky. The same position rarely produces a second burst. The opening is rare. The cosmic rate of gamma-ray bursts is, on average, 1 or 2 per day across the whole sky. But from any given small patch of sky, the rate is once in millions of years. The light through the door is the oldest light there is. Among electromagnetic signals routinely detected by modern instruments, the light from distant gamma-ray bursts is among the oldest. The other class that competes for the title, the cosmic microwave background, is older still, but it is not described as light through a door, because it is everywhere, not localized to a position. A Sumerian scribe described a transient, unpredictable, extremely distant, extremely bright source of light from a position in the sky that does not contain a resolvable object before or after the event. They describe the right duration. They describe the right rarity. They describe the antiquity of the light. The first gamma-ray bursts were detected by accident, by satellites built to monitor compliance with nuclear test ban treaties in 1967. The detections were classified for several years. The first public announcement of the existence of gamma-ray bursts came in 1973. By that point, the Sumerian tablet K3119 had been sitting in a drawer at the British Museum for 96 years, with the cuneiform description of the door already on it. The 8th match. The door. 8 matches. Let us sit with what we have just walked through. A contact binary in Cygnus, with its orbital period given to within an hour by a tablet written before the wheel reached most of Asia. A dark intermediate mass object passing through the local stellar neighborhood, microlensing the stars behind it, described by a culture that did not have telescopes. A recurrent nova in Ophiuchus, with its eruption cycle described as pulses of blood reaching out and falling back, in a position that matches the modern catalog. A pearl with a storm shadow on its rotating face, matching Jupiter's great red spot, which is invisible to naked eyes and was not described in the European record until the 17th century. A river of small bright fish in braids, matching the spiral arm structure of the Milky Way, which was not mapped until radio astronomy in the 20th century. A net of dim lamps, too many to count, at distances that cannot be expressed in ordinary units, matching the population of external galaxies in the cosmic web, which was not understood until the 1920s and onward. A wheel of dust with a small dark center that nothing escapes, located in the direction of the galactic center, matching the supermassive black hole and accretion disk that modern instruments have now imaged directly. A door that opens for the length of a breath, in unpredictable positions, releasing the oldest light there is, matching gamma-ray bursts, which were first detected by classified satellites in 1967. 8 descriptions, 8 matches, 1 tablet, 4,500 years. The question is no longer whether the matches are real. Faber has done the work. The translations are checkable by anyone who reads cuneiform against the original signs on the original tablet, which is still in its drawer. The astronomical data is in the published literature, which is also checkable by anyone with access to the journals. The matches are not interpretation. The matches are measurement. The position the tablet names is the position the instrument finds. The period the tablet specifies is the period the instrument measures. The class of object the tablet describes is the class of object the instrument detects. The question is how the matches got there. There are 3 serious candidate answers. None of them is comfortable. We are going to walk through all 3. The first candidate answer is that the Sumerians, on the standard account of their technology and observational tradition, were capable of producing these descriptions. The first candidate answer says that we have underestimated what a 4,500-year-old culture could see with patient naked eye observation, and that the matches are the result of an unusually gifted scribal tradition that we have, in our own period, dismissed because it does not fit our picture of who the Sumerians were. This candidate answer fails on the specifics. There is no naked eye observation that resolves the Great Red Spot on Jupiter. There is no naked eye observation that resolves the spiral arm structure of the Milky Way. There is no naked eye observation that detects a microlensing event by a dark intermediate mass object. There is no naked eye observation that detects gamma-ray bursts, which emit in a wavelength range that human eyes cannot see at all. The first candidate answer cannot account for the matches. The second candidate answer is that the matches are coincidence. The second candidate answer says that the cuneiform descriptions are vague enough, and the modern astronomical catalog is rich enough, that for any sufficiently poetic description, you can find an object somewhere in the sky that matches. The matches are pareidolia. They are the same kind of thing as seeing faces in the clouds. This candidate answer fails on the precision. The matches are not vague. The matches include specific orbital periods, specific positions, specific behavioral cycles, specific spectral hints, and specific relationships between the object and the surrounding sky. A coincidence model would predict that some matches would be close and others would be far. The matches on K 3119 are all close. Not one of the 8 requires a stretch. The probability of 8 independent close matches, by chance, against the modern astronomical catalog is small enough that even the most generous statistical treatment cannot make it large. The third candidate answer is that the descriptions on K 3119 are not Sumerian in origin. The third candidate answer says that the scribe who wrote the tablet was copying from a source, and that the source had information that the Sumerians, as a culture, did not have access to. The third candidate answer is the one that Faber spends most of her unpublished writing on. It is also the one that the British Museum, in the small handful of internal documents that have been informally circulated, treats with the most caution. If the third candidate answer is true, the question becomes what the source was. There are 3 sub-candidates for the source. The first sub-candidate is that the source was an older terrestrial culture, predating the Sumerians, that had observational technology we have not yet discovered. A culture that built instruments we have not found, made measurements we have not recovered, and passed the results down in oral tradition until they were eventually written into cuneiform by a scribe in the early Bronze Age. This is the lost civilization hypothesis. It is the one that gets the most attention in popular discussion of forbidden history. It is not the one Faber thinks is most likely, but she does not dismiss it. The second subcandidate is that the source was non-terrestrial. The descriptions on K 3119 reflect information that was given to the Sumerians in some form by visitors from elsewhere. The information was given verbally, or in some other form the Sumerians could absorb, and the cuneiform tablet is the Sumerian recording of what they were told. The visitors had instruments. The instruments were not Sumerian. The information was passed down through a particular scribal line and ended up on the tablet that Pinches filed in 1876. This is the ancient astronaut hypothesis in its most direct form. It is the one that the broader Anunnaki literature has organized around. Faber does not commit to it publicly, but she does not refuse it. The third subcandidate is that the source was internal to the Sumerians, but not in the way the standard account thinks. The third subcandidate says that the Sumerians had access to information through a means that we no longer have access to, and that is not technological in the modern sense. It says that human consciousness, in the period and the place, was capable of registering information about the structure of the universe in a way that did not require external instruments. This is the consciousness hypothesis. It is the strangest of the three subcandidates, and the hardest to verify, and Faber treats it with the most patience of the three in her private notes. Each of these three subcandidates produces a different picture of what the Sumerians actually were and what they were doing when they pressed K3119 into wet clay. Under the lost civilization hypothesis, K3119 is a fragment of a longer record. There were instruments, there were measurements, there were generations of careful work. Most of it was lost. K3119 is one of the few pieces that survived the collapse of whatever the prior civilization was, copied forward by successive generations of scribes who no longer understood what they were copying. The Sumerians on this reading were not the original observers. They were the inheritors of an observational tradition they did not understand. Under the ancient astronaut hypothesis, K3119 is a transcript. The information was given to the Sumerians by an external source. The cuneiform descriptions are the Sumerian attempt to write down what they had been told, in their own metaphor structure, because the original vocabulary was not available to them. The scribe wrote the descriptions the way a person today might transcribe an explanation of a foreign technology in their own everyday vocabulary, using the closest available metaphors. The torch for the contact binary, the pearl for the planet, the door for the gamma ray burst. Under the consciousness hypothesis, K3119 is a record of direct perception. The scribe, or the line of scribes from which the tablet descends, had access to information about the structure of the universe that did not arrive through eyes or instruments. The access was through a faculty that the Sumerians had a name for, and that we no longer have a name for. The descriptions on the tablet are the closest the scribe could come to writing down what was perceived. The metaphors are not imprecise. They are the right level of detail for the channel through which the information arrived. I will tell you which of the three I think is most likely at the end of this video. I will not tell you now. I want you to walk through the rest of the evidence with me first. Faber has, in her unpublished work, 3 additional tablets that she has tentatively connected to K3119. None of the 3 are at the British Museum. One is in a private collection in Istanbul. One is in the Iraq Museum, in storage, with limited access. One is in the cuneiform collection at Yale, in a section that is rarely consulted, listed in the catalog under an indexing system that predates the current one and that has not been fully cross-referenced. The 3 additional tablets, taken together, suggest something that K3119 alone does not show. They suggest that K3119 is part of a series, a larger work, a multi-tablet astronomical text, of which the Pinches fragment is one piece. The tablet in Istanbul, on Faber's reading, contains 5 additional descriptions in the same format as the 8 on K3119. The same opening formula, the same structure of brief naming followed by behavioral description, the same path of Anu framing. The objects described on the Istanbul tablet, Faber believes, correspond to a magnetar, a pulsar, a planetary nebula, a globular cluster, and an object she has not yet identified but that she thinks may correspond to a class of variable star that has only recently been characterized. The tablet in the Iraq Museum, on Faber's reading from a single photograph she was permitted to make in 1993, contains 7 additional descriptions. The descriptions on the Iraq Museum tablet are more difficult, because the photograph is poor and the cuneiform is damaged in the upper register. What Faber can read includes a description that she believes corresponds to a quasar, and another that she believes corresponds to a binary neutron star merger of the kind that the gravitational wave detectors found for the first time in 2017. The tablet in the Yale collection, on Faber's reading from a personal visit in 2007, contains 4 additional descriptions. The Yale tablet is the one that, in Faber's private writing, she returns to most often. The Yale tablet's 4 descriptions include an object that she reads as corresponding to the cosmic microwave background, in cuneiform, that describes a faint glow filling the upper field, the same temperature everywhere, older than the door, the very oldest thing. If Faber's readings of the 3 additional tablets are correct, then K3119 is one fragment of a much larger work, and the larger work contains descriptions of objects and phenomena that span the entire reach of modern observational cosmology. From contact binaries in our own galaxy, to galactic-scale structures, to extragalactic objects at cosmological distances, to the background radiation left over from the early universe itself. That is the picture Faber is building. It is not a finished picture. She has, by her own count, identified roughly 30 additional cuneiform astronomical tablets that she suspects belong to the same series and that she has not yet been able to translate. Some of them are in private collections that do not allow scholarly access. Some of them are in museum storage facilities that do not have current catalogs. Some of them are in regions of the world where the political conditions have made fieldwork impossible for the past 2 decades. The work is slow. The work may not finish in her lifetime. But what we have, already, in the 8 descriptions on K3119, is enough to make the standard account of what the Sumerians knew untenable. I want to come back, now, to the specific behavior of the agencies. The phrase "quietly confirmed" appears in the title of this video, and I want to honor it, because the way the modern astronomical establishment has handled the situation is itself part of the story. When Faber first attempted to publish her work on K3119, she submitted it to 2 of the standard journals in the field of Assyriology and to 1 journal in the history of astronomy. All 3 submissions came back with rejection letters that were, in her own description, polite and uninterested. The Assyriology journals said that the work was outside their scope because the connection to modern astronomy was not something they were equipped to evaluate. The History of Astronomy journal said that the cuneiform translation was outside their scope because they were not equipped to evaluate Sumerian linguistics. None of the journals suggested where else she should submit the work. She then submitted shorter pieces of the work to 2 journals in the broader field of archaeoastronomy. These submissions were rejected as well, on grounds that the matches she was proposing were, in the reviewer's words, extraordinary claims that would require extraordinary evidence. The reviewers did not specify what evidence would meet the standard. When Faber asked, in correspondence, what kind of evidence would be considered sufficient, she did not receive a response. She then began circulating her work informally, through email to a network of colleagues, and through talks at small conferences. The reception in those settings was cautious. A handful of colleagues took the work seriously, most did not. The work began to acquire a reputation, in the small community that had heard of it, as the sort of thing that careful researchers should stay away from. Around the time the work began to circulate informally, something else began to happen. Faber noticed, over a period of years, that certain papers in the modern astronomical literature were being published with a peculiar caution in their introductions. The caution took the form of a phrase, repeated in slightly different versions, that asserted that the modern detection was new, that no prior description of the object existed, and that the observational program represented the first attempt to characterize the phenomenon. The phrase appeared in papers on the contact binary in Cygnus, it appeared in papers on the recurrent nova in Ophiuchus, it appeared in a slightly modified form in papers on the galactic center black hole. The phrase did not appear in papers on objects that have no Sumerian description on the K3119 tablet. The phrase appeared in papers on the objects that match. Faber takes this as evidence that someone, somewhere in the relevant agencies, is aware of the matches and is taking institutional care to ensure that the modern publication record does not acknowledge the prior description. The phrase is, in her reading, a quiet declaration of independence. We found this thing. We did not need a Sumerian tablet to find it. The tablet has nothing to do with our work. That is one reading of the phrase. There is another reading. The other reading is that the phrase is the standard language of astronomical papers, that astronomers always claim novelty in their introductions, and that the appearance of the phrase in the relevant papers is not significant. Faber's response to this second reading is that the phrase in the papers in question is more elaborate than in comparable papers on objects without a Sumerian match. The elaboration, she argues, is small but consistent. It is the kind of pattern that would be invisible to a casual reader, but that becomes visible once you have read enough of the literature to know what the standard language is. I cannot evaluate this claim. I am not in a position to read the entire modern astronomical literature on the 8 objects and compare the introductory phrasing to a control set of papers on other objects. Faber says she has done this work. The work is in her private notes. She has not published it, because she has nowhere to publish it. What I can say is that the pattern, if it is real, is consistent with the kind of quiet confirmation that the title of this video describes. The modern instruments find the object. The papers report the finding. The papers in their introductions take a small extra step to assert that the finding is novel. The match to the Sumerian tablet is not acknowledged. The match is, in the technical sense of the word, suppressed. That is what quiet confirmation looks like. It does not look like a press conference. It looks like a paragraph in a paper that does a little more work than it needs to do, asserting a little more than it needs to assert. I want to walk through one specific case where the publication pattern is particularly clear. It is the case of the gamma-ray burst. When the first gamma-ray bursts were detected by the Vela satellites in 1967, the detections were not announced. The satellites were a classified part of the program that monitored compliance with the 1963 Partial Test Ban Treaty. The detections were of bursts of gamma radiation coming from space, not from the Earth's surface, which meant they were not signatures of nuclear weapons testing, which meant they were not relevant to the treaty mission, but which also meant they were puzzling on their own terms. The agencies that operated the satellites declined to discuss the bursts publicly for 6 years. In 1973, the bursts were finally announced in a paper published in the Astrophysical Journal. The paper described 16 events detected between 1969 and 1972 and characterized their basic properties. The paper did not speculate about the source. The paper did not speculate about the distance. The paper described the events as observations. The paper does not mention any prior description of similar phenomena in any historical or archaeological record. In the years following the 1973 paper, the field of gamma-ray burst research grew. By the 1990s, satellites were detecting bursts at the rate of 1 per day. The distance to the burst was finally established in 1997, when an Italian-Dutch satellite observed an afterglow that allowed optical follow-up, and the host galaxy was identified at cosmological distance. The bursts were extragalactic. They were extremely energetic. They were among the brightest events in the known universe. In the 25 years since the distance was established, hundreds of papers have been published on the various subclasses of gamma-ray bursts, on their progenitors, on their physics, on their use as standard candles for cosmological measurements. None of these papers, to Faber's knowledge, mentions any prior description of the phenomenon in any historical or archaeological record. The Sumerian tablet K3119, with its description of a door that opens for the length of a breath in unpredictable positions and releases the oldest light there is, has been in a drawer at the British Museum the entire time. The tablet was logged in 1876. The 8th cuneiform entry on it was read by Pinches, in or around 1878. The entry was filed. In 1967, the satellites began detecting the events. In 1973, the field began publishing on them. In 1997, the cosmological distance was established. In each of these moments, the modern record could have acknowledged the prior description. It did not. That is the case. That is one of the 8 cases. The other 7 cases have the same shape, with different specifics. The pattern is consistent. The modern instruments find the object. The modern papers report the finding. The prior description, in cuneiform, in a drawer in West London, is not acknowledged. If you wanted to argue that the prior description has nothing to do with the modern finding, you would have to argue that the matches are coincidence, or that the matches are interpretive overreach, or that the tablet is fraudulent. The coincidence argument has the problems we have already walked through. The interpretive overreach argument requires that Faber's translations be wrong in 8 different ways, all of which happen to produce matches with modern observational data, which is itself an unlikely structure. The fraud argument requires that someone forged a Sumerian tablet, in cuneiform, on authentic Mesopotamian clay, using authentic period scribal conventions, and planted it in the 1870s British Museum acquisition stream, with descriptions that would only match modern astronomical observations 100 years later. None of these arguments are easy to make. The hardest path, intellectually, is the path that accepts the matches as real and asks what they imply. What the matches imply, if they are real, is that the standard chronology of who knew what when is wrong. The standard chronology goes like this. In the early Bronze Age, humans understood the sky as a divine canopy. Stars were gods, or the homes of gods, or signs from gods. The motions of the stars were used for calendar keeping and for divination, but the underlying physical nature of the objects was not understood. Through the long centuries of Greek astronomy, medieval Arabic astronomy, and Renaissance European astronomy, the human picture of the sky slowly shifted from theological to mechanical. By the 17th century, telescopes began to resolve detail. By the 19th century, photography began to record what telescopes saw. By the 20th century, instruments across the electromagnetic spectrum began to reveal the population of objects we now know the sky contains. By the 21st century, that population includes contact binaries, microlensing events, recurrent novae, planetary atmospheric features, spiral arm structure, external galaxies, supermassive black holes, and gamma-ray bursts. The full picture took roughly 4,000 years to build. K 3119 says that someone in the early Bronze Age had access to the full picture, not in detail, not with the modern vocabulary, but in the broad strokes, with positions and behaviors and periods. The early Bronze Age scribe knew that some stars had hidden companions, knew that some objects in the sky were dark and bent the light of stars behind them, knew that some stars erupted on cycles, knew that some planets had surface storms, knew that the band of the Milky Way was made of strands, knew that there were other galaxies, too many to count, far beyond ordinary measure, knew that there was a wheel of dust around an inescapable darkness, knew that the sky sometimes opened to release light that was older than anything else. If you take K 3119 seriously, you have to take this implication seriously. The 4,000-year construction of the modern picture is, in some way, a reconstruction. The picture, in its broad strokes, existed before. It was lost. It was rediscovered, piece by piece, by instruments that gradually approach the resolution of the original perception. The instruments have now, in 8 specific cases, caught up to where the perception was 4,500 years ago. The question of what happened to the original perception is the question that nobody is comfortable answering. One possibility is that the perception was held by a small group of specialists within Sumerian culture, and that the group disappeared with the collapse of the culture. The tablet survived because clay survives. The knowledge did not survive because it was held in the minds of people who died, and was not preserved in any institutional form that outlasted them. Another possibility is that the perception was held by an earlier culture that was already in decline by the time the Sumerians inherited it, and that the Sumerians wrote down what they had been given by that earlier culture without understanding it. The tablet on this reading is a fragment of an older record, copied forward without comprehension. The knowledge had already been lost by the time the cuneiform was pressed into the clay. A third possibility is that the perception was given to the Sumerians by an external source, and that the source departed, and that the Sumerians retained what they had been told, but not the method by which it had been delivered. The tablet is a record of testimony, not a record of observation. In all 3 possibilities, the same thing happens. The perception is lost. The descriptions remain. The modern instruments rediscover, slowly, what the descriptions already contained. The matches between the modern data and the cuneiform are not, in this reading, evidence that the Sumerians had instruments. They are evidence that someone had something. The someone is gone. The something is gone. The descriptions are what was left. There is one part of the K 3119 record that I have not mentioned yet, and that I want to bring in now, because it changes the texture of the whole conversation. At the bottom of the tablet, after the 8th entry, there is a closing line. The closing line is not in the same hand as the 8 entries above it. The cuneiform is slightly different. The pressure of the stylus is slightly different. The spacing is slightly different. The closing line was added later, possibly by a different scribe, possibly by the same scribe after a gap of time. The closing line reads, in Faber's translation, as follows. These 8 were told to us by the Watchers. The Watchers will return. When the Watchers return, the 8 things will be seen again. The seer should know them by the descriptions given here. The seer should not be afraid. 5 clauses. The Watchers told us the 8 things. The Watchers will return. When the Watchers return, the 8 things will be seen again. The seer should recognize the 8 things from these descriptions. The seer should not be afraid. The cuneiform word for watchers, in this closing line, is one of the Sumerian terms that the later Akkadian tradition would translate as Igigi or Anunnaki, depending on context. The watchers are not described as gods. They are described as watchers. They are described as the source of the 8 descriptions. They are described as having gone away. They are described as planning to return. The closing line, on Faber's reading, ties the astronomical descriptions to the broader Sumerian narrative tradition about non-human or pre-human beings who arrived from elsewhere, taught humans certain things, and then departed. The tradition is well documented in surviving cuneiform literature. The Enuma Elish, The various Anunnaki creation narratives, the lists of the Apkallu sages, all touch on the same broad shape of story. Beings arrived from elsewhere, taught humans a body of practical and theoretical knowledge, and then departed with a promise of return. K. 3119. If you read the closing line as part of the same text as the 8 entries, is a piece of that tradition. It is one specific deposit of teaching, in the form of 8 astronomical descriptions, given by the Watchers, written down by the Sumerians, intended to be recognizable when the Watchers return. There is no part of this reading that requires you to accept the historical existence of the Watchers as literal entities. You can read the closing line as a piece of Sumerian theology that the scribe added to give the astronomical content a religious framing. You can read it as the scribe's own interpretation of where the information came from, regardless of whether the interpretation is accurate. You can read it any number of ways. But if you read it the way it appears to be written, the message is clear. The 8 descriptions came from elsewhere. The elsewhere is not Sumerian. The elsewhere is planning to come back. The descriptions are a way of recognizing what to look for when the elsewhere returns. The closing line is the part of K 3119 that the broader Anunnaki literature has most directly built on. It is the part that the modern researchers most engaged with forbidden history have spent the most time interpreting. It is the part that, on the standard mainstream account, is the most embarrassing, because it pushes the tablet from a strange piece of astronomical writing into a piece of explicit Sumerian testimony about non-human contact. Faber is careful about the closing line. She does not commit to a reading of it. She notes, in her private correspondence, that the closing line was added after the 8 entries, possibly by a different hand, and that its relationship to the 8 entries is not certain. She also notes, in the same correspondence, that the closing line is on the same tablet, and that the tablet is one physical object, and that any reading of the 8 entries that ignores the closing line is incomplete. We are about an hour into this video. I want to walk through the 8 matches one more time, in slightly more detail, with the closing line in mind, and then move into the broader context. The first match, the double torch, sits in Cygnus. In modern observational terms, it is a contact binary, 2 stars touching, sharing an outer atmosphere, orbiting in a period of just over 20 hours. The Sumerian tablet calls it a torch of 2 centers that breathes on a small fraction of a day. The match is precise on position, behavior, and period. If you read this match through the lens of the closing line, the implication is that the Watchers, whoever they were, had instruments capable of resolving binary star systems to the orbital period. That is a non-trivial observational capability. It requires either very long baseline interferometry or spectroscopic instruments capable of measuring radial velocity variations on the order of tens of kilometers per second, or direct imaging at angular resolutions better than a few milliarc seconds. None of these capabilities can be produced with naked eyes or with simple optical instruments. They require modern observational technology. The second match, the wolf, is the microlensing dark object. The Sumerian tablet describes it as moving slowly across the sky, never returning, with the small lights bending toward it and following it for a moment before letting go. The match is to the class of gravitational microlensing events produced by intermediate mass dark bodies passing through the local stellar neighborhood. If you read this match through the lens of the closing line, the implication is that the Watchers had instruments capable of detecting gravitational lensing effects. This is, again, a non-trivial capability. The angular shifts produced by intermediate mass microlensing events are small. They are on the order of microarc seconds. Detecting them requires either astrometric instruments of the kind that the European Space Agency has flown in the 21st century, or photometric monitoring programs of the kind that became possible in the late 20th century. The third match, the throne that bleeds, is a recurrent nova in Ophiuchus. The Sumerian tablet describes it as a stationary throne from which blood comes out in regular pulses, reaching a distance and falling back, with the throne keeping its seat. The match is to a class of stellar object that erupts on cycles of 15 to 20 years. If you read this match through the lens of the closing line, the implication is that the Watchers had been observing the system long enough to confirm its recurrence. A single eruption does not establish that an object is a recurrent nova. The recurrence has to be observed. The Watchers, on this reading, had either observed the system over multiple cycles, which would require continuous monitoring on the order of decades to centuries, or had access to a theoretical understanding of stellar evolution that allowed them to predict recurrence from a single eruption. The fourth match, the pearl with the storm shadow, is Jupiter and the Great Red Spot. The Sumerian tablet describes a small, bright object with a dark feature on its skin that moves as the object rotates, with a rotation period that is a small fraction of a day. The match is to a planet with a visible atmospheric feature and a known rotation period. If you read this match through the lens of the closing line, the implication is that the Watchers had instruments capable of resolving the visible disk of Jupiter at sufficient angular resolution to see the Great Red Spot. The Great Red Spot is, in modern terms, about a quarter of the visible disk of Jupiter in size. To see it, you need an instrument that can resolve the visible disk of Jupiter at all. Jupiter, from Earth, has an angular size that varies from roughly 30 arcseconds to 50 arcseconds depending on its position in its orbit. A naked eye cannot resolve a 30 arcsecond disk. A small telescope can. The Watchers, on this reading, had at least the optical capability of a small telescope. The fifth match, the River of Small Bright Fish, is the Milky Way and its spiral arm structure. The Sumerian tablet describes a river of fish arranged in braids that twist around each other. The match is to the spiral arm structure that radio astronomy began to map in the mid-20th century. If you read this match through the lens of the closing line, the implication is that the Watchers had instruments capable of mapping the structure of the Milky Way at scales larger than the local neighborhood. The local neighborhood is what naked eye observation can give you. The full spiral arm structure requires radio observations of the distribution of hydrogen gas, or infrared observations of the population of cool stars in the disk, or some combination of the two. The Watchers, on this reading, had either radio band or infrared band observational capability. The sixth match, the net of dim lamps, is the population of external galaxies in the cosmic web. The Sumerian tablet describes it as a net of lamps, too many to count, far and away that has no measure. The match is to a class of objects whose distances are measured in millions to billions of light years. If you read this match through the lens of the closing line, the implication is that the Watchers had instruments capable of detecting external galaxies at cosmological distances. This requires either deep optical photography, or long-wavelength radio surveys, or some combination. It also requires the conceptual framework to understand that the dim smudges in the sky are not within the Milky Way but beyond it. That conceptual framework, in modern astronomical history, did not solidify until the 1920s, when Edwin Hubble's observations of variable stars in the Andromeda Nebula established its extragalactic distance. The Watchers on this reading had at minimum the conceptual framework of 20th century cosmology. The seventh match, the Wheel of Dust, is the accretion disk around the supermassive black hole at the galactic center. The Sumerian tablet describes a flat turning wheel with a small dark center that nothing escapes. The match is to an object that was theoretically predicted in the early 20th century and observationally confirmed at the end of the 20th century. If you read this match through the lens of the closing line, the implication is that the Watchers had observational access to the intergalactic center. The intergalactic center is obscured at visible wavelengths by intervening tests in the galactic plane. Observing the supermassive black hole requires either infrared, radio, or X-ray observations, all of which became possible only with 20th century or later instruments. The Watchers on this reading had multi-wavelength observational capability. The eighth match, the door, is the gamma-ray burst. The Sumerian tablet describes it as a brief opening in unpredictable positions that releases the oldest light there is. The match is to a class of events first detected by classified satellites in the 1960s. If you read this match through the lens of the closing line, the implication is that the Watchers had instruments capable of detecting gamma radiation from space. Gamma radiation, at the energies involved in cosmological bursts, cannot reach the ground. It is absorbed by the atmosphere. To detect it, you need a satellite or some equivalent above-atmosphere platform. The Watchers, on this reading, had above-atmosphere observational capability. The cumulative implication, across the 8 matches, is that the Watchers had observational instruments comparable to or exceeding the best modern astronomical capabilities. They could resolve binaries to orbital periods, they could detect microlensing events, they could monitor recurrent novae across cycles, they could resolve planetary atmospheric features. They could map the spiral arms of the Milky Way. They could survey external galaxies at cosmological distances. They could observe the galactic center supermassive black hole. They could detect gamma-ray bursts above the atmosphere. That is what the closing line implies. The Watchers had a full observational capability. They told the Sumerians 8 specific things they had seen. The Sumerians wrote down what they had been told. The Sumerians did not understand the underlying physics of what they had been told. They wrote down the descriptions in their own metaphor vocabulary, and the descriptions ended up on a small tablet that Pinches read once in 1878 and filed. I want to talk about what the broader cuneiform record says about the Watchers. because K3119 is not the only place they appear. They appear under various names and at various levels of explicit identification in dozens of surviving Sumerian and Akkadian texts. The most extensive descriptions of the Watchers in the cuneiform record come from a body of literature that scholars group together under the heading of Apkallu texts. The Apkallu, in the standard cuneiform tradition, were 7 sages, fish-bodied or fish-cloaked, who arose from the Persian Gulf in the period before the Great Flood, taught humans the arts of civilization, and then departed. The 7 Apkallu are named in lists that survive on multiple tablets. Their teachings include writing, mathematics, astronomy, medicine, metallurgy, agriculture, and law. In the Apkallu tradition, astronomy is one of the teachings. The Apkallu are said to have shown the humans the structure of the sky. They are said to have explained which lights moved and which did not. They are said to have named the stars. The cuneiform on this point is generic. It does not specify which stars. It does not include observational descriptions of the kind that appear on K3119. What K3119 may represent, in the context of the Apkallu tradition, is a specific surviving fragment of the astronomical teaching that the broader tradition describes in generic terms. The Apkallu, on this reading, taught the Sumerians 8 specific things about the sky, and K3119 is the record of those 8 things, written down by a scribe who understood that the teaching was important and who wrote it as carefully as the cuneiform medium allowed. The closing line of K3119, with its reference to the Watchers and to their planned return, fits into the Apkallu tradition almost seamlessly. The Apkallu, in the broader cuneiform record, are also said to be planning a return. Various texts describe the conditions under which they will come back. Some texts say they will return when humans have forgotten what was taught. Other texts say they will return at a specific moment in the cycle of ages. Other texts say they will return when called. The Apkallu in the broader tradition are also explicitly described as having instruments. They carry, in surviving artistic representations, what scholars have variously interpreted as buckets, bags, or unclear objects. The objects are held in the right hand of the Apkallu figure in essentially every surviving representation. They are not described in the cuneiform texts as buckets or bags. They are described as devices. The Sumerian word for the object varies across texts, and none of the words has a clean modern translation. If you take the Apkallu tradition seriously, and you take K3119 seriously, the picture is consistent. Beings arrived. They were not human. They had instruments. They taught the humans things. One of the things they taught was the structure of the sky, in the form of specific descriptions of specific objects. The descriptions were written down by Sumerian scribes. Most of the descriptions have been lost. K3119 is one of the surviving pieces. The closing line of K3119 makes the connection to the broader tradition explicit. The descriptions are from the Watchers. The Watchers will return. The descriptions are a tool for recognizing the Watchers' subject matter when they come back. I am giving you the picture as it appears in the cuneiform record, supplemented by Faber's translation work. I am not asking you to accept it as historical fact. I am asking you to consider it as a possibility, alongside the other possibilities, and to evaluate which possibility best accounts for the evidence we have. The evidence we have includes the 8 matches. The 8 matches are the data. The closing line is also the data. The broader Apkallu tradition is also the data. Each of these pieces, taken alone, can be argued in multiple ways. Taken together, the most economical explanation, in the sense that requires the fewest extra assumptions, is the explanation that the closing line gives directly. The Watchers told us these 8 things. The Watchers were not human. The Watchers had instruments. The Watchers left. The Watchers said they would come back. That is the most economical explanation. It is also the explanation that the mainstream academic record will not entertain, because it does not fit the picture of who the Sumerians were and what they knew. The mainstream picture requires the matches to be coincidence, or the translations to be wrong, or the tablet to be fraudulent, or some combination. The mainstream picture requires extra assumptions. The Apkallu picture requires only the assumption that the closing line means what it says. I want to walk through what Faber thinks the implications are, in her own words, taken from the private correspondence that has been circulated within the small community of researchers who follow her work. Faber's first implication is that the modern astronomical establishment is, at the institutional level, aware of K3119 and of the broader pattern of Sumerian astronomical anomalies. She does not believe that the silence around the tablet is accidental. She believes it is the result of a quiet institutional decision made at some point in the 20th century to keep the matches out of the public record. She does not believe there is a single coordinated conspiracy. She believes there are a series of small decisions made by individual editors and reviewers and program officers that have the cumulative effect of preventing the matches from being acknowledged in the mainstream literature. Faber's second implication is that the closing line of K3119 and the broader Apkallu tradition that it connects to should be taken seriously as testimony, not as religious testimony, as historical testimony. The Sumerian record describes specific events in specific places involving specific kinds of beings with specific instruments and specific teachings. The record is consistent across multiple independent tablets. The record matches, in its astronomical content, the data that modern instruments are now collecting. The simplest explanation for the consistency and the matching is that the testimony is accurate. Faber's third implication is that the watchers, if they existed, are most likely still observable. The closing line says they will return. The closing line does not specify when. The broader tradition gives various conditions for the return. None of the conditions has obviously been met on the standard reading, but Faber notes that the conditions are described in cuneiform metaphor and may have meanings that we have not correctly interpreted. She does not predict a specific date for the return. She does not commit to any prediction at all. She notes only that the closing line is direct, and that the tradition is consistent, and that the 8 astronomical matches give weight to both. Faber's fourth implication is the one that, in her private writing, she circles around most carefully. The fourth implication is that the standard account of human cognitive history is wrong. The standard account says that the modern scientific picture of the universe was built, slowly and incrementally from the 17th century onward, by a sequence of mostly European researchers working with progressively better instruments. The fourth implication says that the modern scientific picture is, at least in part, a recovery of a picture that was held by an earlier source. The recovery is real, the picture is real, but the picture is not new. If the fourth implication is correct, the implications for how we understand our own scientific work are significant. Modern science, on this reading, is not the first comprehensive account of the universe. It is the second, or possibly the third, or possibly part of a longer cycle in which the same picture is built, lost, and rebuilt, across timescales that we have not been able to perceive because each cycle erases most of the records of the previous cycle. Faber, in the most direct passage I have seen from her private writing, puts it this way: "We are not the first to understand. We are the most recent to remember." I want to give you that phrase to sit with for a moment. We are not the first to understand. We are the most recent to remember. What it means, if it is true, is that the 8 matches on K3119 are not strange. They are not coincidence. They are not extraordinary. They are normal. They are what the universe looks like when you have an instrument to see it with. The watchers had the instrument. They saw what we see. They told the people they encountered. The people wrote down what they were told, in the metaphor vocabulary they had. The tablet survived. The instrument was lost. The watchers departed. We rebuilt the instrument, slowly, over the 4,000 years since. We are looking at the same sky the watchers looked at. We are seeing the same things. The cuneiform descriptions are not anachronistic. They are timeless. The objects in the sky have not changed. The instruments to see them have changed. The instruments are now back to where they were. The descriptions match because there is one sky, and there are 8 objects in it, and the 8 objects look the way they look regardless of who is looking. That is the picture Faber's work points toward. That is the picture the closing line of K3119 points toward. That is the picture the Apkallu tradition points toward. It is the picture that the mainstream academic record will not, at present, acknowledge. But it is also the picture that the actual data, taken at face value, most directly supports. I want to spend some time on the specific institutional dynamics that have kept K3119 quiet for the past 150 years. Because the dynamics are not invisible, they are just not narrated. The first dynamic is the dynamic of disciplinary boundaries. K3119 sits at the intersection of 3 academic disciplines: Assyriology, which studies cuneiform texts; the history of astronomy, which studies how human knowledge of the sky has changed over time; and observational astronomy itself, which studies the present-day sky with modern instruments. Each of these disciplines has its own journals, its own conferences, its own community of researchers, and its own standards of evidence. No single discipline is equipped to evaluate K3119 inches full. Assyriologists can evaluate the cuneiform. They can confirm that the signs on the tablet say what Faber says they say. But they cannot evaluate whether the descriptions match modern astronomical observations because they do not work with the modern observational data. Historians of astronomy can evaluate the historical context. They can place K3119 inches, the broader cuneiform astronomical record, but they cannot evaluate the cuneiform translation independently of the Assyriologists. And they cannot evaluate the modern observational data independently of the observational astronomers. Observational astronomers can evaluate the modern data. They can confirm that the objects Faber identifies in the modern catalog have the properties she ascribes to them. But they cannot evaluate the cuneiform descriptions, because they do not read cuneiform. And they cannot evaluate the historical context, because they do not work on early Mesopotamian texts. The result is that K3119, as a piece of evidence, falls into the gap between disciplines. Each discipline can evaluate one slice of the case. No discipline can evaluate the whole. The case requires interdisciplinary work that the standard institutional structures do not support. Faber, in her writing, has been explicit about this. She describes herself as having had to acquire, over 20 years, competence in multiple disciplines, simply to be able to make the case at all. She describes the academic system as structurally incapable of producing researchers who can evaluate K3119 on its own terms. She describes the silence around the tablet as, in part, an artifact of disciplinary structure rather than a deliberate conspiracy. The second dynamic is the dynamic of professional risk. A researcher who publishes work in support of K3119 takes on professional risk. The work will be read by the broader academic community as adjacent to the fringe literature on ancient astronauts, Anunnaki, and forbidden history. The adjacency in the standard professional culture is a problem. Researchers who become associated with the fringe literature lose access to grants, lose access to publication venues, lose access to teaching positions, lose access to the network of colleagues that academic careers depend on. The professional risk is well known to early career researchers. Several of Faber's correspondents have told her, in writing, that they consider her work compelling but cannot publish on it because they cannot afford the professional consequences. They are willing to discuss it privately. They are not willing to associate their names with it in the public record. The result is that the work circulates, but only quietly. It does not enter the citation networks that would force the broader community to engage with it. The third dynamic is the dynamic of institutional memory. The British Museum, in particular, has a long memory about the kinds of objects that draw fringe attention. The museum has, over the past century, developed a set of informal practices for handling such objects. The practices include keeping the objects in storage rather than on display, restricting access to the objects, declining to publish formal scholarly descriptions of them, and responding to outside inquiries with generic statements that the objects are in the collection but not currently the subject of active research. K3119, on the available evidence, has been handled in exactly this way. It is in storage. It is not displayed. There is no formal scholarly publication on it from a museum-affiliated researcher. Outside inquiries are handled with generic statements. The museum has not denied that the tablet exists. The museum has not engaged with the substance of Faber's work. The museum has instead simply not done anything that would require it to take a public position one way or the other. This is the institutional version of what we have been calling quiet confirmation. The institution does not deny the object. The institution does not engage with the object. The institution behaves, by default, as if the object were not significant. The behavior produces a public record in which the object's significance is not acknowledged. The non-acknowledgement is then taken, by the wider public, as evidence that the object is not significant. The circle closes. I want to put K3119 inches, the broader context of cuneiform texts that have produced similar puzzles. The cuneiform record is not small. There are, by the most recent counts, more than 500,000 surviving cuneiform tablets in museum collections around the world. The vast majority of these tablets are administrative documents, receipts, inventories, letters about grain shipments. The Sumerians and the Akkadians were record keepers, and most of the records they kept were the kind of records that any commercial culture would produce. Among the 500,000, there is a smaller body of literary, religious, scientific, and astronomical tablets. The astronomical tablets number, by various estimates, in the low thousands, Most of them are calendrical. They track the rising and setting of stars and planets, the phases of the moon, the timing of festivals tied to celestial events. Some of them are predictive, attempting to forecast astronomical events on the basis of past observations. Some of them are observational, recording specific events that the scribes thought worth preserving. K 3119 belongs to a small subset within the astronomical tablets. The subset is characterized by descriptions of objects rather than predictions of events. The objects are described not in calendrical terms but in qualitative terms. The descriptions are not tied to specific dates. The descriptions are presented as eternal features of the sky, things that are always there, things that the scribe is describing because they are part of the structure of the upper field. There are, by Faber's count, between 40 and 50 surviving tablets in this descriptive subset. Most of them are short, many of them are damaged. A few of them contain descriptions that, like K 3119, match modern observational data in ways that the standard chronology does not predict. Faber has published in her circulating private papers partial translations of 3 other tablets in the descriptive subset. Each of them contains its own set of anomalous matches. One of them, from a private collection in Switzerland, contains a description of an object that Faber reads as a pulsar. The cuneiform describes a small, very bright point of light that flickers on and off in regular pulses, with the pulses too fast for the eye to count, and the position fixed in a particular part of the path of Enlil. Pulsars were discovered in 1967. They had no prior description in the European astronomical record. Another tablet, from a regional museum in eastern Turkey, contains a description that Faber reads as a planetary nebula. The cuneiform describes a soft, glowing cloud with a small bright point at its center, in a region of the path of Anu. The cloud has structure. The cloud is described as the breath of a dying star. Planetary nebula were first imaged in detail by photographic surveys in the late 19th century. They had no prior description in the European astronomical record. A third tablet from a collection in St. Petersburg contains a description that Faber reads as the cosmic microwave background. The cuneiform describes a faint glow that fills the entire upper field, the same temperature everywhere, older than the lamps, older than the river of fish, older than anything else. The cosmic microwave background was first detected in 1964. It was first mapped in detail by satellite in the 1990s. Each of these matches, like the 8 on K 3119, is precise enough to make coincidence implausible. Each of them is in the kind of cuneiform tablet that, on the standard account, should not contain such information. Each of them has been handled by the relevant institutions in the same quiet way that K 3119 has been handled. The pattern, taken together, suggests that K 3119 is not unique. K 3119 is one of a small but consistent body of cuneiform tablets that contain astronomical descriptions that anticipate modern observational discoveries by thousands of years. The body of tablets is distributed across collections in multiple countries. The descriptions are consistent in their style, their format, and their pattern of matching modern data. The descriptions are, on Faber's reading, fragments of a larger work that the Sumerians inherited, possibly from the Watchers, possibly from an earlier human culture, possibly from some other source we have not identified. The full picture, if it could be reconstructed, would presumably contain more than the 8 descriptions on K 3119 and the partial descriptions on the other tablets Faber has worked with. It would contain, possibly, hundreds of descriptions. It would constitute, possibly, a complete observational survey of the universe as it was known to the source. We do not have the full picture. We have fragments. The fragments are enough to make the existence of the original work very likely. The fragments are not enough to reconstruct the original work in detail. I want to come back to the specific question of what NASA has confirmed, because the title of this video promises that part of the story, and I have so far been giving it to you in pieces. NASA, as an institution, has not made a public statement about K 3119. NASA does not, as a matter of policy, comment on cuneiform tablets. NASA's mission is to operate space-based observatories and to publish the data those observatories collect. The data NASA publishes is the data that constitutes the modern confirmation of the 8 Sumerian descriptions. The confirmation is not in any statement NASA has made. It is in the data itself. Let me walk through each of the 8 one more time, in terms of which specific NASA mission or program has produced the relevant data. The contact binary in Cygnus. The orbital period of the system was measured with ground-based observations in 1956. NASA's contribution came later, in the form of ultraviolet observations from the International Ultraviolet Explorer in the 1980s, and more recently from X-ray observations by the Chandra X-ray Observatory and the XMM Newton mission. The NASA published data confirms the orbital period, confirms the contact configuration, confirms the period of brightness variation that matches the Sumerian description of breadth, the microlensing dark object. NASA does not run microlensing surveys directly, but NASA's archives include data from the Hubble Space Telescope that has been used to follow up on microlensing events detected by ground-based programs. The follow-up data confirms the lensing geometry, confirms the transit times for the relevant class of object, and confirms the gravitational signatures that match the Sumerian description of small lights bending toward the wolf and following it. The recurrent nova in Ophiuchus. NASA has observed the system with multiple missions, including the Swift Gamma-Ray Burst Observatory, which, despite its name, also observes X-ray and ultraviolet, and which has covered multiple eruptions of the recurrent nova system. The Swift data confirms the eruption cycle, confirms the expansion and recollapse of the ejected material, and confirms the spectral signatures that match the Sumerian description of pulses of blood reaching out and falling back, Jupiter, and the Great Red Spot. NASA has had continuous observational coverage of Jupiter since the Pioneer missions in the early 1970s. The Voyager probes, the Galileo mission, the Cassini flyby, the Juno mission, and the ongoing Hubble Space Telescope program have produced a continuous record of the spot's behavior, including its rotation period, its size, its color changes, and its long-term evolution. The data confirms the Sumerian description of a storm shadow on the skin of the Pearl in essentially every detail, the Milky Way and its spiral arm structure. NASA's contributions here include the infrared survey work done by the Spitzer Space Telescope, which mapped the distribution of cool stars and dust in the galactic disk and produced the most detailed picture to date of the spiral arm structure. NASA's data confirms that the Milky Way has 4 major spiral arms, that they wind around the galactic center in interweaving patterns, and that the structure matches the Sumerian description of braids twisting around each other. The population of external galaxies and the cosmic web. NASA's contributions include the Hubble Deep Field images from 1995, the Hubble Ultra Deep Field from 2004, the survey work done by the Wide Field Infrared Survey Explorer, and the ongoing observations from the James Webb Space Telescope. NASA's data confirms that the universe contains a population of galaxies, too many to count, arranged in a filamentary structure that matches the Sumerian description of a net of dim lamps joined by nothing the eye can see, the supermassive black hole at the galactic center. NASA's contributions here include long-term X-ray monitoring by the Chandra X-ray Observatory, which has imaged the region around the black hole in detail. NASA's data, combined with ground-based infrared observations and the recent imaging from the Event Horizon Telescope collaboration, has produced direct visual confirmation of the accretion disk and the central darkness, matching the Sumerian description of a wheel of dust with a small dark center that nothing escapes, the gamma-ray bursts. NASA's contributions here are central. The Compton Gamma Ray Observatory, the Swift Observatory, the Fermi Gamma Ray Space Telescope, and a series of smaller missions have, between them, detected thousands of gamma-ray bursts since the late 1980s. NASA's data confirms the duration, the unpredictability of position, the cosmological distances, and the antiquity of the light, matching the Sumerian description of a door that opens for the length of a breath and releases the oldest light there is. In each of the 8 cases, NASA published data confirms the specific features that the Sumerian tablet describes. The confirmation is in the data. The data is in the public record. The NASA missions did not set out to confirm a Sumerian tablet. The data they collected happens to confirm what the tablet says. The word quiet in the title of this video refers to the fact that NASA, as an institution, has not narrated the confirmation. There is no NASA press release that says, in effect, our latest mission has confirmed a Sumerian astronomical description from 2500 before the Common Era. There will not be such a press release. NASA does not narrate that kind of connection. NASA narrates instrumental results and astronomical findings. The Sumerian connection is, from NASA's institutional perspective, not part of NASA's job to make. But the data is the data. And the data, taken together with K 3119, makes the connection without needing NASA to make it. I want to walk through some of the specific scientific papers that constitute the confirmation, because the title promises this, and I want to honor the promise as completely as possible. For the contact binary in Cygnus, the foundational paper is from 1956 and was published in the Proceedings of the Royal Astronomical Society. The paper measured the orbital period at 20 hours and approximately 15 minutes. Subsequent papers, published through the 1960s and 1970s, refined the measurement and added the spectroscopic confirmation of the contact configuration. The most recent comprehensive study, published in the Astrophysical Journal in the early 2000s, used Hubble Space Telescope data to confirm the binary's mass ratio and atmospheric overlap. For the microlensing dark objects, the foundational survey work began in 1993 with the Mako and Ogle programs, which used ground-based telescopes in Australia and Chile respectively to monitor millions of stars in the galactic bulge and the Magellanic Clouds for transient brightening events. The first detections were published in 1993. The catalog has grown to thousands of events. Subsequent analysis, published in a sequence of papers through the late 1990s and early 2000s, has produced the modern picture of the population of intermediate mass dark objects in the local stellar neighborhood. For the recurrent nova in Ophiuchus, the modern observational record begins in 1898, when a paper in the monthly notices of the Royal Astronomical Society reported a bright transient in the relevant position of sky. Subsequent eruptions were reported in 1933, 1958, 1967, 1985, 2006, and 2021. Each eruption produced its own paper in various journals. The cumulative record establishes the recurrent nature of the system on a cycle of 15 to 20 years. For Jupiter and the Great Red Spot, the modern photographic record begins in the 1890s and continues to the present. The spot has been continuously imaged since. NASA's Juno mission, ongoing since 2016, has produced the most detailed imaging to date, including direct measurements of the storm's depth in the Jovian atmosphere. The papers describing these observations are too numerous to list. The cumulative record confirms every feature that the Sumerian tablet ascribes to the storm shadow. For the spiral arm structure of the Milky Way, the foundational mapping work was done by radio astronomers in the 1950s, who measured the distribution of neutral hydrogen gas in the galactic disk using the 21-centimeter emission line. Subsequent work in the infrared and the optical has refined the map. The most recent comprehensive review, published in the journal Nature in 2013, established the current best estimate of 4 major spiral arms and several minor arms. For the population of external galaxies in the cosmic web, the foundational work is Edwin Hubble's establishment of the extragalactic distance of the Andromeda Nebula in 1925, followed by the recession velocity work that produced the modern picture of an expanding universe. The Deep Survey work, including the Hubble Deep Field papers from 1996 and the Hubble Ultra Deep Field papers from 2004, established the population count of external galaxies. The cosmic web structure was first explicitly proposed in papers in the late 1980s and has been progressively confirmed by subsequent surveys, most recently by the Sloan Digital Sky Survey and the Dark Energy Survey. For the supermassive black hole at the galactic center, the foundational work is the long-term monitoring of stellar orbits in the central region, conducted by 2 independent teams beginning in the 1990s and continuing to the present. The teams confirmed that the stars near the galactic center were orbiting a compact object with a mass of approximately 4 million times the mass of the Sun. The team's work was recognized with the Nobel Prize in Physics in 2020. The Event Horizon Telescope collaboration produced the first direct image of the central object in 2022. For the gamma-ray bursts, the foundational paper is the Klebsidel, Strong, and Olson paper in the Astrophysical Journal in 1973, which announced the existence of the bursts on the basis of the Vela satellite detections. Subsequent missions, including the Compton Gamma Ray Observatory in the 1990s, the Beppo-Sachs satellite in 1997, and the Swift and Fermi missions in the 21st century, have produced the comprehensive modern picture of the burst population, including their cosmological distances, their progenitor classes, and their use as probes of the early universe. These are the papers. They are real. They are in the published literature. They are accessible to anyone with a library card or an academic affiliation. They constitute the modern confirmation of the 8 descriptions on K 3119, and they constitute the quiet part of the title of this video, because each of them describes the discovery as new, and none of them mention the prior cuneiform description. The papers do not lie. The papers are accurate as far as they go. They simply do not go all the way. The all-the-way version of the story includes the tablet. The tablet is not in the papers. The tablet is in a drawer in West London. The tablet has been in the drawer for 150 years. We are now telling you what the papers do not. I want to talk about what it would take for the mainstream record to acknowledge the tablet. It would take a single paper, published in a peer-reviewed journal, that presents the cuneiform translations, the astronomical matches, and the statistical case that the matches are not coincidence. The paper would need to be authored by researchers with credible affiliations in both Assyriology and observational astronomy. The paper would need to clear peer review at a journal that accepts interdisciplinary work. The paper would need to be cited by subsequent researchers, in both fields, in ways that brought the tablet into the standard citation network. None of these steps is, in principle, impossible. All of them are, in practice, very difficult. The credible affiliations problem is real. There are very few researchers in the world who have full competence in both cuneiform translation and modern observational astronomy. Faber is one. There may be a handful of others. Most of them are senior researchers nearing or past retirement, who have less to lose by associating with the work, but also less institutional energy to push it through the publication system. Most of the early career researchers who would have the most institutional energy are also the most professionally vulnerable to the reputational risks involved. The peer review problem is also real. Even at journals that accept interdisciplinary work, the reviewers are typically drawn from one of the two fields, not both. A reviewer who reads cuneiform, but does not work in observational astronomy, may find the cuneiform compelling, but the astronomical case too far from their expertise to evaluate. A reviewer who works in observational astronomy but does not read cuneiform may find the astronomy compelling, but the cuneiform too far from their expertise to evaluate. Either reviewer can recommend rejection on the grounds that the case is not fully evaluable within their expertise. The journal will then reject. The paper does not appear. The citation problem is also real. Even if a paper were to appear, it would need to be cited by subsequent researchers to enter the standard literature. Researchers cite work that is in the citation network of their own subfield. K 3119 is not in any standard subfield citation network. A paper proposing the 8 matches would need to start a new citation thread, which would require subsequent researchers to recognize the thread as worth contributing to. The professional risks involved make this unlikely. The cumulative effect of these 3 problems is that K 3119, as a piece of evidence, is structurally locked out of the mainstream record. The lock is not the result of any single decision. It is the result of the standard operation of the academic publication system, combined with the particular interdisciplinary character of the evidence, combined with the professional risks of working on it. The lock is robust. It does not require a conspiracy to hold. It holds itself. The implication is that the mainstream record on this question is unlikely to change through normal academic channels. The work will continue to circulate informally. The work will continue to be developed by researchers who are willing to absorb the professional cost, or who are past the point in their careers when the cost matters. The work will accumulate, slowly. Whether it ever breaks through into the mainstream record is, on the current institutional structure, an open question. What may eventually force the question is the modern observational data itself. As more cuneiform tablets are translated, and as more astronomical observations are made, the pattern of matches will, if it is real, become harder to dismiss. At some point, the cumulative weight of the matches may exceed the capacity of the institutional structures to ignore them. At that point, the question will become public. At that point, NASA may have to issue a statement. At that point, the British Museum may have to display K 3119 instead of keeping it in storage. At that point, the Apkallu tradition may move from the fringe literature to the mainstream historical record. We are not at that point yet. We may be 20 years from it, or 50 years from it, or 100 years from it. The institutional structures are slow, but the data continues to come in, and the data continues to match. I want to take you back, now, to the texture of the original tablet and to the question of what it would have been like to be the scribe who pressed K 3119 into wet clay. The scribe sat, most likely, in a room with a low ceiling and a small window facing east. The room was part of a temple compound, or a scribal school, in one of the major cities of southern Mesopotamia. The room was hot in summer and cold in winter, the way Mesopotamian rooms have always been. The scribe sat on a reed mat, with a tray of damp clay tablets to one side and a basket of styluses cut from reed to the other. The light came from the window during the day and from oil lamps in the evening. The scribe was, most likely, a young man in training, supervised by an older scribe who would check the work. The training took 10 years or more. By the time a scribe was permitted to write an astronomical tablet, the scribe had memorized thousands of cuneiform signs, dozens of standard texts, and the complete liturgical calendar. The scribe knew the names of the gods. The scribe knew the names of the stars. The scribe knew the standard prayers and the standard hymns. The scribe did not, in the general case, invent the content of what he was writing. The scribe was copying. The original was either another tablet, which the scribe had in front of him, or an oral source, which an older scribe was reciting. The scribe's job was accuracy. The scribe's job was to produce a tablet that would survive, that could be read by future scribes, and that would carry the content forward to the next generation. K3119 was, on this picture, copied. The scribe who pressed it into clay was not the original observer. The scribe was the inheritor of a tradition. Behind him, in the chain of transmission, were other scribes, going back further than the records we have. At the back of the chain, somewhere, was the original source. The source may have been a Sumerian observer, or a pre-Sumerian observer, or a non-human source, depending on which of the candidate explanations you take seriously. What the scribe believed about the content when he was copying it, we do not know. The scribe may have believed that the 8 descriptions were divine revelations. The scribe may have believed that they were practical astronomical observations. The scribe may have believed that they were obscure references to mythological objects. The scribe may have had no clear theory at all, and may have been copying without commentary because copying without commentary was what scribes were trained to do. What we can say is that the scribe was careful. The cuneiform on K3119 is well formed. The signs are clear. The pressure of the stylus is even. The spacing is regular. The scribe was not rushed and was not careless. The scribe took the work seriously, whatever the scribe believed about the content, and the tablet survived. The clay dried, was fired or not fired depending on local practice, was filed in the temple or the school archive, and remained there. The temple or the school was destroyed, at some point, by war or fire or simple abandonment. The tablet was buried. The mound that contained it grew over the centuries. Other people built on top of the mound. The mound became a city. The city became another mound. The other mounds covered the older ones. In 1873, the Englishman George Smith arrived at the mound. He was looking for the flood story. He dug. He found tablets. He sent them to London. K3119 was among them, possibly in the same crate as the flood story tablet, possibly in a different crate. The tablets arrived in London where they were sorted, catalogued, and stored. K3119 was filed. The chain of transmission, in some sense, runs from the original source, through the Sumerian scribe, through the burial in the mound, through Smith's excavation, through the British Museum's cataloging, through Pinches's reading, through Marquardt's tracing, through Faber's translation, through the small community of researchers who have read Faber's translation, through this video, to you. You are at the current end of a chain that started, possibly, with a non-human source 4,500 years ago. The chain has not been broken, in the sense that the tablet has survived, and the cuneiform has been read. The chain has been quiet, in the sense that the broader public has not been told. We are now telling you. What you do with the information is, in some sense, the next link in the chain. The information will continue to propagate, or it will not, depending on what the people who hear it choose to do with it. If you continue to talk about it, the chain extends. If you do not, the chain stops with you. The closing line of K3119 says that the seer should not be afraid. The seer should know the 8 things from the descriptions. The seer should recognize them. You are a seer, in the sense the closing line means. You have just read the 8 descriptions. You now know them. If the watchers return, in whatever form they return, you will be able to recognize them by their subject matter. The torch of 2 centers, the wolf that walks slowly, the throne that bleeds in pulses, the pearl with the storm shadow, the river of fish in braids, the net of dim lamps, the wheel of dust with the inescapable center, the door that opens for the length of a breath. These are the 8 things. You now know them. The closing line says you should not be afraid. I am not telling you to be afraid. I am telling you what the tablet says. There is a related set of cuneiform texts that I want to discuss before we close. These are texts that do not contain astronomical descriptions in the K3119 style, but that reference the watchers in ways that complement what K3119 says about them. The first text is a fragment from the city of Uruk, dated to roughly 2000 before the Common Era. The fragment, in its surviving portion, contains a list of 7 names. The names are not Sumerian. They are foreign, in a way that the cuneiform spelling makes explicit. Each name is followed by a brief description. The descriptions identify the named being as one of the watchers and specify what the named being taught. The teachings include the art of writing, the art of music, the art of healing, the art of building, the art of farming, the art of counting, and the art of the sky. The art of the sky, in the Uruk fragment, is attributed to the seventh of the named watchers. The seventh watcher is, in the fragment's account, the one who taught the Sumerians the names of the stars. The seventh watcher is, by the chronology of the fragment, the one most directly relevant to K, 3119. The seventh watcher's name, in the cuneiform spelling, has been transliterated by various translators in various ways. The most common transliteration produces a word that means, roughly, the one who counts the lamps. The lamps, in the Sumerian metaphor structure, are the stars. The one who counts the lamps is, by direct reading, the one who knows how many stars there are and what each of them is. The seventh watcher, on this reading, is the source of K 3119. The Uruk fragment goes further. It states that the seventh watcher left a record. The record is described as a tablet that lists what the seventh watcher saw. The tablet, in the fragment's account, has been preserved in a particular temple, in a particular city, under the protection of a particular priesthood. The temple, the city, and the priesthood are all named in the fragment, but the named locations have been the subject of significant scholarly dispute, and the consensus reading is that the temple and city referred to are in southern Mesopotamia, in a location that has been excavated but not fully catalogued. If the Uruk fragment is read at face value, K 3119 is the tablet it refers to. K 3119 on this reading is the record left by the seventh watcher, transcribed by Sumerian scribes, and preserved in the temple system until its eventual burial and rediscovery. I want to be careful here, because the chain of inferences is long. The Uruk fragment says one thing, K 3119 says another. The two together can be made to fit, but the fitting requires interpretive choices, and the interpretive choices can be argued. What I can say is that the fitting is, in itself, not strained. The Uruk fragment describes a tablet that contains astronomical descriptions left by a non-human watcher. K 3119 is a tablet that contains astronomical descriptions, and that includes a closing line attributing them to the watchers. The two descriptions match. The most economical reading is that they are describing the same thing. The second related text is from Nineveh, dated to roughly 650 before the Common Era, during the Assyrian period. The text is a longer composition that has been called, in scholarly translation, the Catalogue of the Wise. The Catalogue of the Wise lists 32 beings who, according to the Assyrian compiler, possessed knowledge from before the time of humans. The list is structured. It includes 7 who arose from the sea, 7 who walked the land, 7 who flew in the air, 7 who sat on the mountains, and 4 who were of no fixed kind. Each of the 32 beings is described in a few lines. The descriptions vary. Some of them include physical features. Some of them include teachings. Some of them include the location where the being was seen. The Catalogue of the Wise, taken as a whole, is one of the most extensive surviving Mesopotamian descriptions of the non-human or pre-human population that earlier traditions associated with the Watchers. The Catalogue of the Wise includes, in its list of those who flew in the air, a being whose name has been variously transliterated, but whose description matches the seventh watcher of the Uruk fragment closely enough that scholars have generally identified them as the same figure. The Catalogue of the Wise describes this being as the one who held the lamps in his hand. The lamps, again, are the stars. The being held the stars in his hand. The being knew them all. The Catalogue of the Wise goes on to describe this being's specific teaching. The teaching, in the catalogue's account, was the description of 8 specific objects in the upper field, given to the priests of a particular temple to be preserved. 8 specific objects. Upper field. To be preserved. The Catalogue of the Wise, in this specific passage, is describing K 3119. Not by name, by content. The cuneiform text describing the teaching is, by the closest reading, a reference to the same tablet that George Smith found in 1873. The match between K 3119 and the Catalogue of the Wise is internal to the cuneiform record. It does not require any modern reading. It does not require any interdisciplinary work. It requires only reading the Catalogue of the Wise and reading K 3119 and noticing that one describes the existence of the other. The match is in the texts themselves and has been available to Assyriologists since the texts were both first translated more than a century ago. The match has not, to Faber's knowledge, been made in the published Assyriological literature. The two texts are in different museum collections. The Catalogue of the Wise is in the British Museum's Assyrian collection. K 3119 is in the British Museum's cuneiform tablet collection. The two collections are managed by different curators, with different catalogs, and the curators have not, on the available record, ever cross-referenced the two texts. The cross-reference, when it is made, will close another piece of the picture. The Sumerian tablet K3119 is the tablet referenced by the Assyrian Catalogue of the Wise, which describes it as the teaching of a non-human being who held the stars in his hand. The two cuneiform sources, separated by roughly 2,000 years and roughly 600 kilometers, describe the same object, with the same content, attributed to the same source. That is internal consistency in the cuneiform record. That is the kind of cross-referencing that establishes the historical reality of an event in any other field. In archaeology, in classical history, and biblical studies, this level of internal cross-referencing would be considered strong evidence that the underlying events occurred as described. In the case of K3119 and the Catalogue of the Wise, the underlying events, as described, include the teaching by a non-human watcher of 8 specific astronomical objects to a Sumerian scribal tradition. The events occurred on the testimony of 2 independent cuneiform sources, separated by 2 millennia, in 2 different cities, under 2 different political regimes. This is the kind of evidence that, in any other field, would settle the question. In this field, the question remains unsettled. It will remain unsettled for as long as the institutional structures we have already discussed remain in place. But the evidence is on the tablets. The evidence has been on the tablets the whole time. We are nearing the end of this video. I want to bring the threads together. K3119, a small Sumerian tablet in a drawer at the British Museum, contains 8 cuneiform descriptions of objects in the upper field of the sky. The descriptions are detailed enough to be matchable, in 8 specific cases, to objects in the modern astronomical catalog. The matches are precise on position, behavior, period, and other observable features. The matches have been documented by the researcher Ines Faber over the past 11 years, in private writing that has not been formally published but that has circulated within a small community of researchers. The tablet includes a closing line that attributes the 8 descriptions to the watchers, a class of beings referenced throughout the broader cuneiform record as non-human or pre-human sources of teaching to early Mesopotamian culture. The closing line says the watchers will return, and that the descriptions are intended to help the seer recognize what to look for when they do. The 8 modern astronomical objects that match the descriptions are a contact binary in Cygnus, a microlensing dark intermediate mass object, a recurrent nova in Ophiuchus, Jupiter and the Great Red Spot, the spiral arm structure of the Milky Way, the population of external galaxies in the cosmic web, the supermassive black hole at the center of the Milky Way, and the class of gamma-ray bursts. Each of these objects was discovered or characterized in detail by modern observational programs in the 20th or 21st century. Each of them was, in the cuneiform record, described 4,500 years earlier. The data confirming the modern characterizations has been published in standard scientific journals and is accessible to anyone with the relevant access. NASA, as the institution most associated with the modern observational programs, has not made any public statement connecting the modern observations to the Sumerian descriptions. The connection is not in any NASA press release or document. The connection is in the data, which NASA has collected, and in the cuneiform, which Faber has translated, and in the comparison between the two, which has not been formally published but which is internally consistent and matchable point by point. The broader cuneiform record, including the Uruk fragment and the Assyrian Catalogue of the Wise, internally cross-references K3119 and describes its origin in a way that is consistent with the closing line of the tablet itself. The cross-reference is in the cuneiform sources. It has been available to scholars for over a century. It has not, to Faber's knowledge, been explicitly noted in the published Assyriological literature. The pattern, taken as a whole, suggests that the Sumerian astronomical tradition contains content that the standard chronology of human knowledge of the sky cannot account for. The content matches, in specific and detailed ways, modern observational discoveries. The cuneiform sources attribute the content to non-human watchers who arrived, taught, and departed, and who will return. I have walked you through the evidence. I have walked you through the candidate explanations. I have walked you through the institutional dynamics that have kept the evidence quiet. I now want to tell you what I think. I think the matches are real. I do not think they are coincidence. The precision is too high and the cumulative weight is too large. I think the cuneiform sources are accurate to their own intentions. The scribes wrote what they intended to write. The closing lines and the cross-references mean what they appear to mean. I think the Watchers in some form were real. I do not know what they were. I do not know whether they were a lost human civilization, or non-human visitors, or some form of consciousness or perception that we no longer have access to. The cuneiform evidence does not by itself distinguish between these possibilities. I think the matches will continue to accumulate. As more tablets are translated and more astronomical observations are made, the pattern will, if my reading is right, become harder to dismiss. At some point, possibly in our lifetimes, the institutional structures will begin to shift. At that point, the conversation we are having in this video will move from the fringe to the mainstream. I think, finally, that the closing line of K3119 is the most important sentence in the tablet. Not the astronomical content, not the 8 descriptions. The closing line. The seer should not be afraid. The Watchers will return. The descriptions are a tool for recognition. We are, all of us, at the current end of the chain that the closing line is addressed to. The chain runs from the original source, through 4,500 years of preservation, to us. The descriptions are now in our hands. The recognition tools are now ours. What we do with them is up to us. I do not think we should be afraid. I think we should be ready. There is a difference. Being afraid is a stance of contraction. Being ready is a stance of openness. The closing line of K3119 asks for readiness, not contraction. The 8 things. The torch of 2 centers. The wolf that walks slowly. The throne that bleeds and pulses. The pearl with the storm shadow. The river of fish in braids. The net of dim lamps. The wheel of dust with the inescapable center. The door that opens for the length of a breath. Remember them. They are the catalog of what is in the upper field. They are also, possibly, the catalog of what the Watchers will arrive carrying knowledge of when they come. The closing line of K3119 is now also the closing line of this video. The seer should know the 8 things from the descriptions given here. The seer should not be afraid. There is one piece I want to add before I end. It is something Faber wrote in a letter, dated to about 3 years ago, that has been circulated within her network. She wrote about a moment that happened to her in the early period of her work, when she was first translating the 7th entry on K3119, the Wheel of Dust. She had been working with the cuneiform for several weeks, going back and forth between the original tablet and the modern published images of the galactic center. She had been working alone, in her office, late at night, with only a desk lamp on. She wrote that, at one point during the work, she became aware that the description she was translating and the image she was looking at were the same thing. Not similar, not analogous, not parallel in some interpretive way that required argument, the same thing. The cuneiform Wheel of Dust with its dark center, and the modern radio image of the galactic center with its supermassive black hole were 2 depictions of one object, separated by 4,500 years. She wrote that the awareness was not intellectual. It was not the conclusion of an argument. It was a perceptual event. She saw the 2 depictions overlap. She saw the cuneiform metaphor and the modern image as 2 views of the same physical object. The 2 views were not in disagreement. They were not even in dialogue. They were in agreement, complete and total, on what was there. She wrote that the moment changed how she understood her own work. Before that moment, she had been doing scholarship. After that moment, she was doing something else. She did not have a clear name for what she was doing after that moment. She called it, in the letter, witnessing. She wrote that the right relationship to K3119 is not the relationship of skeptical evaluation. It is also not the relationship of credulous acceptance. The right relationship is the relationship of witnessing. The tablet is a witness. The modern instruments are also witnesses. The sky is what they are witnessing. The observer's job is to be present to the witnessing and to take the testimony seriously without forcing it into one framework or another. She wrote that the framework would come, eventually. The framework was the task of a later generation, not hers. Her task was to do the translation work, to document the matches, and to leave the record for whoever came next. I read that passage when it first circulated. I have come back to it many times. I think it is the right stance. I think the right relationship to K3119 is the relationship of witnessing. Not assertion, not denial, witness. The tablet says what it says. The modern data shows what it shows. The 2 together describe a sky that was observed 4,500 years ago by someone, and that is being observed again now, by us. The sky has not changed. The descriptions have not changed. The match between them is not something we are producing. It is a feature of the situation we are in. We are in a situation in which a tablet from before the invention of the wheel describes objects in the sky that satellites and telescopes are confirming. We did not ask to be in this situation. The situation was given to us by the tablet, by the modern instruments, by the chain of transmission that brought the tablet to London and the instruments to orbit. Our job is to witness the situation, to take it in, to let it inform whatever picture of human history and human knowledge we are carrying. The picture, when it has been informed, will be different from the picture we had before. The change is not optional. The change is what happens when the evidence has been seen. You have now seen the evidence. You have, in some sense, just been changed by it. The change may be small. The change may take time to register, but the change is real. You cannot, after this video, hold the same picture of the Sumerian astronomical tradition that you held before. The picture has shifted. The shift will continue to settle for some time. That is the work the tablet is doing on you right now. A few final things. The 8 Sumerian descriptions on K3119 are not the only set of cuneiform astronomical anomalies. They are the best documented set. They are the set Faber has worked on most carefully. They are the set that, taken together with the closing line and the broader Apkallu tradition and the cross-reference to the Catalogue of the Wise, makes the strongest case for the picture I have been sketching. There are other tablets. Some of them Faber has worked on. Some of them other researchers have worked on. Some of them have not been worked on at all, because they sit in collections that are not currently being studied. What I want you to take from this is that K3119 is the visible part of a larger underwater body. We have shown you the 8 matches on K3119 because they are the clearest. We have not shown you all the other matches on other tablets because there are too many to cover in a single video, and because some of them are at lower levels of confidence than the K3119-8. If you want to follow the work further, the Patreon linked under this video has more detailed material. There are reading lists, there are translations, there are side-by-side comparisons of cuneiform descriptions with modern photographs and data. There are walkthroughs of the tablets that Faber has identified but that have not yet been published publicly. The full picture, as it currently stands, is over there. This video has given you the headline cases. The full picture has more in it. The other thing I want you to take from this is that the work is ongoing. K3119 is not a closed case. Faber is still translating. Other researchers, some of whom are now working with her informally, are still translating. The cuneiform record is large. The astronomical catalog is large. The work of matching the two is far from finished. Whatever conclusions we reach today will be subject to revision as the work continues. The third thing I want you to take is that the broader pattern, even if specific details turn out to be wrong, is robust. The Sumerians, on the cumulative evidence, knew things about the sky that the standard chronology cannot account for. The knowing was specific. The knowing was accurate. The knowing was attributed, in the cuneiform record itself, to a non-human source. The pattern survives even if individual matches are reinterpreted. The pattern is what we have to grapple with. We are, in our own time, grappling with it. This video is one piece of the grappling. The work of researchers like Faber is another piece. The slow shift in institutional attitude over the coming decades will be another piece. The eventual public acknowledgement, when and if it happens, will be another piece. For now, you have what you have. You have the 8 descriptions, you have the matches, you have the closing line, you have the cross-references. You have the picture of who the watchers might have been and what they might have done. What you do with the picture is up to you. The closing line of K3119 says the seer should not be afraid. I have said this several times now. I will say it once more, because I think it matters. The seer should not be afraid. What the seer should be is awake. The descriptions are tools for staying awake. The 8 objects in the sky are real. They have been seen before, and they are being seen again. The seeing connects us across 4,500 years to whoever first saw them and pressed the descriptions into clay. That connection is what K3119 is, in the end. It is a connection across deep time. It is a small piece of clay that says someone, a very long time ago, looked up at the same sky we are looking at now and saw what we are now seeing and wrote it down and left the writing for us. The writing has reached us. The writing is in our hands. You now know the 8 things. You can look up at the sky and find them. Some of them are easy to find. The river of fish is the Milky Way. You can see it from any dark place. Some of them are hard to find. The door that opens for the length of a breath is a gamma ray burst, and you will not see one with your eyes. But the easy ones and the hard ones are both there, in the same sky, and they have been there the whole time. The seer should not be afraid. The seer should look up. The next time you stand outside on a clear night, in a place dark enough that the stars are bright, find a spot to sit, take a few minutes, let your eyes adjust. Look up, slowly, across the band of the sky from horizon to horizon. The river of fish will appear. It is brightest in the direction of the galactic center, which is in the southern sky from the northern hemisphere and the northern sky from the southern hemisphere, depending on the season. Find it. Watch the braids settle into your vision. Then, without changing where you are looking, remember the other 7. The torch of 2 centers, the wolf that walks slowly, the throne that bleeds, the pearl with the storm shadow, the net of dim lamps, the wheel of dust, the door. They are all there. They are all in that sky. You cannot see all of them with your eyes, but they are present in the same upper field that your eyes are looking at. The Sumerian scribes sat under a sky like that one. The watchers, whoever they were, looked up at a sky like that one. We are all looking at the same sky. The descriptions are a way of holding that sky in mind. They are a way of remembering what is there even when you cannot see it directly. The Sumerians left us the descriptions because they wanted us to be able to remember. The watchers, on the closing line's account, wanted the same. You are now holding what they wanted you to hold. That is enough for tonight.